Hello everyone, am I audible to all now?
Yes, you are audible.
Okay, I was just waiting for this confirmation for a long time. Okay, thank you. Thanks for joining on time. I can see people are still joining. So shall we proceed?
Yes, I can.
Okay, that's good. So let me log into my account, AWS account, right? I hope you remember, right? Last week we have started with our AWS instance with the Kubernetes installed. We have three nodes, one with master and two worker nodes. Hope you all remember that.
Yeah, I
Did you
do.
get chance to work on it or what's the progress?
Yes, I tried for a couple of times, but I get an error while joining the notes with the master. I don't know why.
Mithun, could you please increase your volume? Like,
Yeah, now it's audible.
yeah,
Sorry.
now it's better. Now it's better. Yeah.
Okay. Actually, I tried to join. I mean, get an error when I try to join the nodes with the master, and I posted in the group, WhatsApp group, but I think no one has replied. I mean, if anyone has tried and got successful, but no one replied. So I followed all the steps that you like had gone through during the last session, and I tried couple of times. I mean, I took Ubuntu 20.0 LTS, that instance. I mean, that version. And but I don't know why, I could not be able to join that nodes with the master when we execute that command. uh
Join command. You
yeah,
mean join command, huh?
join command, yeah.
Okay. So,
Everything was successful. I mean, the configuration on master and nodes were successful, but when we join the nodes on the nodes, we execute the join command. So at a time I get an error.
mhm.
I don't know what was it. I mean,
No. So from your Ansible, I mean, what do you call that? Kubernetes controller machine or
yes,
master. Can you able to run the pods?
yes, I can be able to run the pods. I can see that master node was I mean, control plane, it was showing when I executed that command,
No, no,
kubectl get pods.
no. Kubectl get pods will not show you the control plane. It will get you the list of pods that is up and running.
Okay.
Okay, let me share my screen. Where is it?
If
So
you
this is
want to see that screenshot, I can share on the, I mean, in the chat box. Just a moment. Let me share it over here.
Hi, Doctor Sir. Can you please make me co-host?
oh yes, sir. Sure. Co-host. Yes, it's done, sir. Thank you.
Thank you, sir.
So,
If you can see that I put it in the chat box. Um, you know, the screenshot.
okay. Yeah, I'll look into it. No, I got your point. What you're saying is, I got your point. But the thing is, I just want you to verify one thing here, like whether your pods are up and running or not. That matters. So it clearly says that invalid token. There is some issue with the token. Couldn't validate the identity of AP server. Invalid discovery token. PS search. 32 bytes of information. Whatever you shared, it is incorrect. So what you can do is, let me log into my console first. So I believe this is a P server, right? We have created last week. What I did. Okay, it is starting, right? So I can see servers are coming up now. Hope you remember, right? The commands, whatever we have discussed on that day. So if you can recollect this, hope you all can hear me.
Yes, I can.
Yes. So if you give kubectl get nodes, you'll be getting the list of nodes that includes your control plane. So at this point, you'll be getting only control plane, correct? But
Yes.
apart from this command, I was expecting this command to be executed. So kubectl get pods hyphen all followed by the namespace hyphen namespaces. So when you execute this command, you can able to see the list of namespaces that are associated to your Kubernetes master and the nodes. These are all some system pods and everything should be up and running. The status should be up and running here. This is what expected. And in your case, I believe it's all up and running, right?
I did not go further because I got an error while joining. So
No. See, before you issue the join command, you should have validated this.
okay,
And then you should validate this also.
right.
Check with this command and let me know if all these things are up and running. And then you can able to use your token to validate it. And as per the error message, it clearly says that invalid token, right? The token is
Yeah.
invalid. So you can
SHL
able, yeah, you can
256.
able to generate the token now. So you just forget about it, just execute the command. Cube ADM token create along with the print. I just shared this command in note documents already.
On Kubernetes master, and
Yeah,
then
in Kubernetes
okay,
master, you run this command, it
yeah,
will generate this token.
okay,
And once the token is generated, just copy the entire token, starting from this cube ADM till the last byte of the token, you will copy it properly.
right.
If you
But
miss
before
more than
that,
50 byte, it will throw an error. Just copy completely and just paste this in your worker node 1 and 2.
yeah, and before that, I mean, before we run this, create command, I mean, token create command, I have to that re-verify again kubectl get nodes or namespace on master node. I mean, just to check whether it's listing or not.
No, once you're done with this command, then only you can able to verify your worker nodes in master.
Okay, I did not go further after executing this. That's what the problem is. So
First, you need to execute this command in the target node.
yeah, I did it. I did it.
Yeah, that the token is invalid. Okay, in your case, I think you copy pasted the same or what?
Yeah, I just took the as it is.
That is what.
And
See, this IP address is pointing to my machine.
no, not this one. I
Hmm.
mean, after like on master node, when I get this command,
All right.
I took it copied
Okay,
from
then
the
do one
master
thing,
node.
just regenerate the token and try again. Hmm?
All right.
And before you generate the token, just execute the command, like kubectl get pods command and verify that all the system components are running successfully.
Okay. All right. Can you please text it? I mean,
It's
that
already there
command.
in your class notes actually. I hope you received class notes, right? Last week you shared, no?
Yeah. Okay. It should be there then. No problem. I'll do that.
Don't do it now, okay? That's what I don't want to ping it now. You can do it offline because you didn't learn something new. So
Yeah.
just go
Later.
with the flow. You can practice all these things once we're done with the session. Hmm? So shall we continue now, all of you,
Yes.
guys? So like this, any other questions from anyone? Anyone have any other question on this?
Sai, your voice is little bit low. Can you please come closer to mic?
Is it better now, or is it
Yes,
how
yes,
others
yes,
are
yes.
feeling?
Now it is better.
Okay. Okay. Hope it's better, right? We can continue now. Okay. Guys, shall we continue now? Is it better to everyone? What's up?
Yes. Please proceed.
Okay. So just a quick recap of what we discussed on Kubernetes. Like we are started with the architecture of Kubernetes, right? So where we discussed about various Kubernetes components, starting from your API server, scheduler, kube proxy.
Sorry,
your
sorry.
kubelet-
Again, it went low, your voice.
Hello, is that better
Yeah,
or what?
for us, it is fine, Sai. I think only problem with that guy alone. We are hearing good.
Okay. Uh, sorry, who's that? I don't find his name. So please, can you please check from your end once? I think others can able to hear properly.
Yeah, now it is fine, sorry.
Okay, fine. So we were discussing about the various components of Kubernetes architecture, starting from API server, your scheduler, controller manager, etcd, and then also we discussed about some of the properties of the pods, right? So what is a pod basically? Pod is the smallest unit of task that you can able to run on your Kubernetes, right? So whenever we talk about the deployment in Kubernetes, we never directly deploy the container. The containers are, packed and deployed in the form of pods. A pod can have one container or it can have multiple containers. It depends upon the requirement. And did we discuss about the pod networking, right? On the day last session, I was talking about the pod network, how the interpod communication happens, intrapod communication happens. And whenever the pod is created, the pod will be allocated with the unique IP address, right? So now we are going to talk about something related to your networking. I think we have covered. So as far as Kubernetes is concerned, we are going to talk about these things now. Okay. So today is 28th. Day 9. So tomorrow is the last working day, right, for us. So today we'll be covering this Kubernetes and then we'll be starting with your monitoring tool. So now when we talk about the deployment control object, okay, so this is used to maintain the pods in its desired state. So ultimately, the main objective of deployment control object is used to maintain the pods in its desired state. So it maintains the replicas. It perform upgrade or no rollback. It can able to scale up or scale down. Correct. So these are the various capabilities of the deployment control object. But if you're talking about a simple pod, means the pod is just to run some applications in the form of container. That's all. But we never perform any sort of auto scaling or upgrade or downgrade with the help of pods. Pod is just a smallest unit of task. So if you want to enable pod with some additional capabilities like auto upgrade or rollback, or if you want to scale up or scale down, for that we are relying on the deployment control object. So first I'll show you how to create a pod. Okay, and we'll see how to work with kubectl CLI. So 1 minute, I think my machine is up and running. Let me log into my mobile through mobile system. Where is it? Pods, deployment controller objects. I think this is enough. Right. Here it is. Okay, so let's get into our Kubernetes master now. What is this? Oh, what is it? What is it? What is it? What is it? This is the one. Okay, so now that we are in Kubernetes master node, if I say kubectl get nodes, I should be able to get the list of nodes that are associated to my Kubernetes master, right? And similarly, if I say kubectl get pods - all namespaces, right? So you can able to see all my Kubernetes components, like we talked about etc, API server, controller manager, kubeproxy, scheduler, core DNS, all these components are up and running. So it means my cluster, whatever we have created, it is working as expected. And I can able to see my worker nodes are also connected successfully, right? So now, if I simply use a term like kubectl get pods, I can see there is no resources found in the default namespace. So what it mean here? We never created any pod at this point of time. And whenever we create any pod, the pod will be deployed in the default namespace. So in Kubernetes, we have an important concept called namespace. I'll just give you a quick overview of it. Later point of time, I'll show you a demo on that. So namespace is nothing but a logical partitioning of Kubernetes cluster. Got it? It is a logical partitioning of a cluster. So the entire cluster is logically partitioned, and within the partition, we are going to deploy some pods. So the partition, it can be anything. It can be default, or it can be a kube funnel and kube system. So if you see here, whenever we give kubectl get pods, it will get you the namespace along with the name of the pod which you're running and what is status of it. So in my default namespace, there is no pods as of now we have created. So that's why it is empty. But as part of the installation, it has created some pods and it's all up and running in the system namespace and the funnel namespace. Like this, what are namespaces available? You can able to check it out from here. Get namespace. Kubectl get NS. NS means namespace. It will get you the complete list of namespaces available in your system. So out of that, the default namespace is something used by the application teams to deploy the pods. And apart from this, if you want, you can able to create your own namespace also. Got it? So in general, the namespaces are created based upon the application team or based upon the environments. I'll talk about that in detail, okay, in some time, but as of now, understand just logical partitioning. So now we're going to create a pod. So to create a pod, the very first thing is we have to create the manifest file. So remember, manifest file is written using YAML scripts, right? Guys, hope you remember, right?
Yes.
So in the architecture diagram I showed you, we have a manifest file where we define the requirement. What is the name of a pod, which image it is to refer, and what is the name of a container it's going to use, and what is a port, container port. Everything will be defined in this manifest file. Once the manifest file is ready, you'll be using a kubectl command to run that execute the manifest file or submit the manifest file. So I'll show you how to write a manifest file now. There is a small quick example for you. So if you look into this example here, listen carefully. We have something called nginx-pod.yaml. This is the name of the file I'm going to create. And within the file, this is the configuration. So it's whenever we write any Kubernetes manifest file, it can be written in YAML file or it can be in a JSON file. But we use YAML file for quick updates. So whatever it is, it should have 4 important keys. First thing is about the kind. Kind means it is used to identify the type of object you want to create. If your intention is to create a pod means the kind will be pod. Got it? And based upon the object type, the API version will be defined here. So for pod, the API version is v1. For pod, the API version is v1. Because there are various objects available, Kubernetes objects like pods, deployment controllers, replication controllers, replica sets, a lot of things are there. Even the services, what we're going to cover now. So whenever we talk about the object, right, each and every object has its own API version. So the pod is something considered as the object that was created in the very initial stages. The very earlier version of Kubernetes has this pod object. So these are all part of the core group, core API group. So that is the reason we simply use v1. But if you're talking about deployment means it will be having a different API version. So first thing is identify the object type and then identify the API version of that object and then the metadata, the next important key. So this metadata is going to identify the name of the object you want to create. So now I'm going to create an object called nginx-pod. So this is a name I can able to specify here. And for any object you create, you can able to assign some label. Labels are not mandatory, but it is recommended to have it as a best practice. Because every time I can't rely on the object name to refer the object, right? I need some alternate name or alternate tag to refer it. Okay, so for that purpose, I can assign some labels. So labels are used to assign some additional tag to your object. And once you identify the object name, the next thing is about the specification. So it means I'm going to create a pod based upon which image and the container it is going to run. That matters. So I can, all the container specification of the pod will be under the specification here. Just give a containers and we can give an image. I'm going to refer the image called nginx image. This nginx image is available in your Docker Hub. So I want to use this image and create a container within the pod. The container name is nginx-container. And since this is an nginx, it by default runs in port 80, right? So container port is 80. We can specify here. So this is the way you'll be creating your manifest file. So identify the object type and the API version, metadata to identify the name of the object you're going to create, and the specification that is going to have your container specification. It can be container name, image, and the pods. Easy? Is it clear? Any doubt here, guys?
I just want to know the structure of metadata. I mean, why we have to define the labels?
As I said, labels are just an alternate tag that is assigned to your object. Okay, let's say tomorrow I can able to map this object to any of the service, or I can able to map it to any of the team or application. For that, I can able to refer this particular label. Let's say, for example, consider I have application team. Listen carefully. I have an application team, and assume that application team name is AD1. And that application team might create a number of objects, right? They can create a number of pods. They can create a number of deployment control objects, services, everything. So each and every object they create, the name of the object should be unique. But they can able to assign a tag called application name, like AD1. That's what the label, additional tag that you are assigning to that object. So tomorrow, if I want to filter, if I want to get the list of all the pods that is created by that AD team, means I can able to use a label to filter it. Easy. So
Okay.
if you want to apply some filter and get the list of objects based upon certain parameter, we can able to make use of the labels.
We can define the name as unique. So is that mandatory if we don't, I mean, put this label over here for this metadata? If the name is unique, then
Come again.
let's say we have this YAML file and now we have this Nginx app, right? So we are going to create a container of, this Nginx. So now, if we don't define label and this name would be unique, so in that case, we have to define labels mandatory,
See,
or is
I
it
told
okay?
you, right? Labels are not mandatory, but as
Okay.
a best practice, we use labels, right? You are considering this as only one object now, but going forward, you'll be creating a number of pods for a specific team, right?
Yes, in that
You'll
case,
be,
okay.
so as a best practice, you just apply some label. Through label, you can able to filter it out.
Yeah.
It is not mandatory, but it is recommended as a best practice. Even without this label also, I can able to make it successful. There's no problem. So once the manifest file is ready, apart from that, any other questions from others, please? I can see most of you are silent.
The metadata name will be unique, right?
The key, right? This one or this one?
This one, Nginx pod.
That should be unique.
Okay, for every object when we are creating, we used to use new name.
See, whenever you create any object, it will get allocated in one namespace, right?
Okay.
So within the namespace, the object name should be unique.
Okay.
Let's say, for example, here, you can able to see cube-system is a namespace. So within this namespace, you can see these many objects are created, right? So all names are unique here. Clear?
Yeah, got it.
So once the manifest file is ready, you will be using a kubectl commands. That's what I just given here. Once the manifest file is ready, then you'll be using your kubectl commands to submit that manifest file for pod definitions. So what I'm going to show you here is, I'll be creating a pod using kubectl command. Kubectl create -f followed by the name of the file. We are not going to give a name of the object. Directly we can give the file name. That's what the syntax, because the file name has all the definitions. So which object you want to create, it has the content. So based upon that definition, it creates the object. And once object is created, if you want to explore, if you want to get the list of pods, or if you want to get more information about the pod, you can able to use some options like -o wide and all the stuff. And then describe command is used to get more information about the pods along with the events. And then I'll show you how to log into the pod and create some simple HTML file, and we'll see how to expose it to the service also. Right. So throughout this module, we're going to discuss about your pod creation, the services, deployment control objects, and the namespaces. So now let me create this file here. So here we have, I just create one folder and I'm going to create a file here. Just a file name, nginx-pod. It can be any name, okay, for your reference. Go to insert mode and keep the content here. So any doubt in writing this manifest file, guys? Are you comfortable in this file? Or do you have any question?
I just want to know this API kind metadata and specification. Those should be in one line, right? And the rest are
Yeah, in the same column. That's what the name, label, and all. It is part of metadata. That's why we just give 2 character space and aligned it. And similarly, under specification, we have containers, right? So
yes.
it matters. So now just save the file. And once the file is ready, you can simply use the command kubectl create command to create the object. Kubectl create -f followed by the file name. Kubectl create -f followed by the file name. So when you execute this command, you can see the pod nginx-pod has been created. Now if you say kubectl get pods, you should be able to see the pod is created and the container is in creation process. So in few seconds, it is up and running. So this is the way we deploy the pod in the Kubernetes environment. So once a pod, it is something like a container, okay? Like once a pod is created, I told you a pod will be allocated to the unique IP address, right? If you can recollect my last session, every pod we create, the pod will be allocated with a unique IP address. Where is it? Where is it? Somewhere here I mentioned, no? Yes. So it will be allocated with unique IP address means you can use a parameter -o void parameter to get the complete information of the pod. So the Nginx pod, whatever you deployed, it is in running state, and this is a unique IP address assigned to this pod. And now it is deployed in worker node 1. This pod is deployed in worker node 1. So how this IP address is assigned? Any idea? Any guess?
It's cluster.
So if you recollect our last day's session, while initializing a Kubernetes master node, we use a kubeadm command, remember? Init pod network CADR. So based upon this pod network CADR range, it is allocating an IP address for your pod. Clear? And this is purely done by your front network plugin. The plugin, whatever you installed, the front network plugin, right? This plugin, because this is going to take care of your pod networking. So now the pod is up and running. Okay, what else you can do? Let's say
Okay, I have a doubt. We didn't mention anything about in which node we have to deploy the pod, right? Worker node 1, in worker node 1, how it is deployed? I'm
See,
not.
that is what yesterday we discussed, right? In the last session, it is a response of the scheduler to identify the healthy node. Correct?
Okay, if it is getting from the first node itself, if it is healthy, it will be deployed in that node.
Yeah, that's right. So to deploy the pod, it is a completely scheduler's responsibility to identify the healthy node, and it takes care of the allocation. Okay. So this is about your IP address. To get the IP address, we use -o void option, and also there is something called YAML file. So if you want to view the complete configuration of your YAML script, you can able to use a parameter like pod name followed by the YAML file definition. So the YAML file, whatever we have created, is just a small content here, right? Just a small pod definition along with content definition. But this YAML file is actually interpreted and created in this manner. So internally, your etcd, I told, right, etcd maintains the complete information of your Kubernetes cluster. It is a complete, it is considered data source for Kubernetes. So within the etcd, this is how the manifest file is stored. So where we have given the API version, pod type as pod, and labels whatever we are saying, the name of the pod whatever we given, and it is running in default namespace, right? And what is the name of a container we have created, which image it is running there, what is the container port. So it just maintains the complete information about the pod internally in the etc database. So if you want to retrieve those details, you'll be using a parameter called -o YAML. All right. Similarly, we have something called describe command, kubectl describe. Kubectl describe pod followed by the name of a pod. So this describe command also is a very important thing in real-time environment. Usually whenever we talk about troubleshooting, let's say I just deployed a pod, but the pod is not up and running. Or sometimes the pod will be up and running, but we won't get the status application. So in that case, how we can able to diagnose the issue means by using describe command. So describe command also try to pull the data from your etcd only. From this entire manifest file only, it is, I mean, YAML file only is going to get the information, but it gives you complete statistics of your pod or any object for that matter. It has the name of the object, namespace, and node name, in which node it is running, and when it is deployed, and what is the IP address of the pod, and what is the container name. Nginx container is the name of a container, right? Name of a container. And image is Nginx image. And in Docker Hub, this is what the container ID and the image ID, whatever it is generated. And this is a container port 80. And status of the container is up and running. Clear? And apart from all these things, the very important thing is about your events. So events are something very much important, something like a log. It's like a catalog, like starting from the creation process, what are the activities we did in the spot, everything will be recorded. That's what the event here. So tomorrow, if you want to diagnose the issue, we need this catalog actually. Like whether it started or what is the progress, who interpreted, how long it was running, is there any interruption happened or not? Everything can be viewed from this event list. So in Kubernetes, whenever you want to diagnose any issue or if you want to deep or troubleshoot any issue, the very first thing what we do is we use a describe command and understand the various events that happen on that object. All right. Is it clear? So this is about your basic kubectl commands. Once the object is created, you can able to verify it by using get commands and describe commands. Now I'll show you how to log into the pod. So in container, we use exec, right? Docker exec command. Remember? How to log into running container means by using docker exec-it. Similarly, here, if you want to log into your pod, we can use kubectl exec-it followed by the name of the pod. Kubectl exec-it followed by the name of a pod in bash or sh mode. So it will get into the default directory of your container. And from that path, we can able to create a file in interactive mode. Just I'm going to create one small HTML file there to print a small message. And then I'm going to exit from that. So once it is done, then I'm going to expose that pod to internet, because whenever we create any pod, right, the pod is executed or the scope of a pod is within the network, within the cluster, because it is having its own unique IP address. That IP address, whatever generated for that pod, you can't use it for external machine. So if you want to access it through external servers, means external machine means you have to expose it through a service called node port service. So that's what the next topic here. So here we have something called services. So there are various types of services in Kubernetes. Like we have something called cluster IP service. We have something called node port and a load balancer. We have ingress, we have external service. A lot of things are there, but we are going to focus on node port service in this program. So what does the need for node port service means? It is used to expose the pod to internet. That's it. Because whenever we create any pod, the scope of the pod is within the network, within the cluster. If you want to access it through web browser, let's say I am running one web application in this pod. How can I access my web application through browser? For that, I have to expose it to node port. So when you expose it node port means it is something like in a container we discussed about port mapping. Remember, port mapping and port binding. Guys, are you online or?
Yes,
Yeah,
we got it.
in Tomcat in Docker we added, right?
In container, we use port
Yeah.
binding. It means using the host port and the container port, we just mapped it. If you want to access any of your application running inside the container, you have to map that container port with the host port, right? Like I showed you demo on Tomcat also, right? Similarly, here I have some applications running, Nginx application running inside my pod. And if I want to expose it to internet, I can't rely on the host port because I'm not sure in which port, in which host machine the pod is deployed, right? It is purely done by the scheduler. If I'm sure that in this node my pod is running means I can able to identify the port number there. But I'm not sure in which host machine, in which worker node the pod get deployed. So in that case, I can't rely on the port number of the host machine. So for that, I need a common port called node port. So node port means it is a service that helps to expose your pod to internet. So when you create a node port, right, it creates some port number randomly, starting from 30,000 range. 30,000 to 30,767. That is the range of the node port. So based upon the range, it creates one unique port number. And once you get the port number, using the port number and the external IP address of the machine, you can able to access your application. So this port is something 31424. What I'm showing here, it is a node port, which is generated when you expose it. Clear? So let me show you that once. So now let's log into our kubectl and create a file first. What is it? Kubectl xcc it followed by the name of the pod that is up and running. And now I can simply copy this content, whatever I have here. It is just a process of logging to the, currently I'm inside the pod and I can able to create the entire HTML file here in this default directory of Nginx. For Tomcat, we have something called web apps, right? Similarly for Nginx, it is user/Nginx HTML to keep all our HTML files and exit from that pod. Once we edit the container, we have created a file and now this web application is running inside this pod. So if you want to access it, you'll be using your kubectl expose command. Kubectl expose pod followed by the name of the pod. The pod, whatever I created, let's say, if you want before that, kubectl get pods. This was the name of a pod. Similarly, there is a command called svc. This is to get the list of services. As of now, there's only one service called Kubernetes service that got created at the time of installation, and it is of type cluster IP. There is an internal service that is up and running for Kubernetes. Now, what we're going to do here means we are going to create a new service. So when you say kubectl expose pod using this node port, it is going to create a new service for this particular pod of type node port service. And this node port, whatever is going to generate, it is going to map it with your container port. The container port is 80, whatever we are given here. So this is what we are not going to map with our host port, but the container port will map to your node port here. It's done. Now, if you get the list of services, you can able to see there is a new service created of type node port, and it is assigned with the node port value 32473. It's a random value which is generated, and it is mapped to my container port. Now, if I want to access the pod through internet, all that I can do is I can simply use the external IP address of the machine along with the port number. So let me go to my machine here. Take the public IP address of the machine where your pod is up and running. You have seen, right? It is running in Worker node 1. So I'm just taking the IP address of Worker node 1 and I'll be updating it here. Got it? And the node port, whatever you've seen here, that is 32473. So this value is required to access your port. So with this, if you're access your browser, you should be able to see the default page Nginx image which is running into the container. It is accessible now.
And
Is
what
it?
if we have multiple replicas of the same, what we can say, the pod? If
It will get deployed in different nodes, right? We can able to use that IP address and access it.
yeah, in different nodes, but here node port service, how it would tackle, like, as you said, it will the port would be created for the node port service. But if the node is having multiple replicas, I mean the pod is having, and those would be on.
One node port is sufficient for that. How many
Oh,
replicas you have, that doesn't matter. Even if you have 100 replicas also, with a single node port service, we can able to access it.
okay.
It is just a replica, copy of the pod, right?
Yeah.
So can you able to see this now? How I access my application through browser? Guys?
Yes.
So all that we did is we have created a pod and it is deployed in the Kubernetes cluster. And that pod is running on application, Nginx application. That application can be accessible through internet using a node port service. So in order to create node port service, we can quickly use our ad hoc command, kubectl expose pod followed by the name of the service and type of the port. Simple. So this is the way you'll be creating your services.
One thing I didn't understand, while exposing the pods, okay, you told in which node it will be running, we will be getting confused, right? So here, if we if we want to connect through external IP, then we have to identify the node. It it doesn't connecting, like I mean, it doesn't matching, which you told previously. While exposing, you told in which node port, I mean, in which node it will be getting, I mean.
No, while exposing, it won't identify any node. It just maps your container port with your node port. That's all. It will generate one unique node port value here, like 32473 something.
Okay.
But the external IP address, whatever you can see here, the external IP address, whatever you can see here, right?
Yeah.
That external IP address, that you can able to get it from your list. That's the reason I execute this command earlier, -o void.
Okay, okay.
So when you run this command, like kubectl get pods -o void, you'll be getting the pod along with the node details in which workload is running. So I can see that this pod is running in worker node 1. So I just took that external IP address of the node.
Okay, is this the only way we have to
Yeah,
we
that's
can
right.
connect?
That's
Okay.
right. Because that is how we expose our application, right? Through the external IP address of the machine in which node it is running, through that IP address only we can able to access the application, right? That matters.
Yeah. got it.
Okay. So this is about the pods and accessing it. So once a pod is ready, if you're okay with this, you can able to make use of it. Or if you don't want it anymore, you can simply use the delete command, delete it. So kubectl delete followed by the name of the pod. This is a command to delete it. Or if you want to delete a service also, you can use kubectl delete followed by the name of the object we can able to use. So any question here? So this example covers almost all the scenarios to work in a pod. Usually whenever we create any pod, first we will verify whether the pod is up and running or not, in which node it is up and running, that we'll verify. And then we'll try to give a describe command to identify all its properties. And then we'll try to access the application that is running inside the pod by using the node port service. So I create node port service also here. And this is one way of creating node port service by using kubectl ad hoc commands. So same service can be created using manifest file also. So that I'll show you tomorrow. Tomorrow, once we start working with our objects deployment, right, I'll show you how to work on that. I mean, how to create a manifest file to create a service, that I'll show you in the next session. So this is how the process goes if you talk about any pod definitions and accessing. All right. So any other questions here, guys? Are you good for this? So now the point here is the pods, whatever we have deployed, kubectl get pods. So this pod is deployed in worker node 1 and my application is running inside the pod. So what if this pod got deleted accidentally, or if it got crashed, or what if this worker node itself it's down? What will happen?
We will use the, I mean, Kubernetes will have the replica, right? So,
But we never
so
define any replicas at this point, right? So as of now, just a simple pod definition without any replications and all. So that is what the basic property here. But now we create any pod, the pod can be meant for the particular application. That's all. It's the smallest unit of task. But if you want to ensure high availability of this pod, we never create the pod directly like this in any real-time environment. All that we do is we create some deployment control objects like this. So it's a very important topic. Please pay attention. So here, if you look into this definition, hope it's visible to all, right? Okay. So here in this case, if you noticed, we have something called kind that is of type deployment. So if you want, I can compare it with my previous document. So this is for the pod definition. And this is for the deployment object definition. We are talking about this now. Okay, deployment object. So here the kind is what happened? Okay, so we are talking about deployment object. So here the kind type is deployment, and API version for deployment object is app/v1. If it is a pod, we just simply say v1, but here it is app/v1. And the metadata that is going to identify the name of the object, and the labels that is going to identify the additional property or a tag for the deployment object. And then the specification that is going to have the replicas, and the template that is going to have the actual pod definition. So it means in a simple pod definition, all that we did is we have created this metadata. The entire definition, whatever we had here in a simple pod definition, it's all kept under the template in your deployment control object. Can you able to see this? So A template will be having the metadata, the name of the pod, what are you going to create, or label of the pod, and then the specification of the container. It should have a container name and the image and the port number. So image, if you want, you can give a latest. If you want to use the latest, means just simply give the name of the image. But here I want to go specific with version 1.7.9. That's the reason I just have it here. And the container port. Got it? So now the point here is we have a template. The template that is going to identify the pod definitions and the container specification, right? And our intention is to replicate this template. I need to have 3 pods, 3 copies of pod of same configuration. Got it? We just want to have a replica of this actually. So in order to replicate this template, we have to notify the deployment object. So how the deployment object is going to identify the template means by using the label, whatever you define here. Clear? So the label whatever defined in the template, that is used to identify the template. So that label name should be maintained in the selector. So as far as deployment control objects are concerned, we have something called labels and selector. So using labels and selectors only, your deployment object can able to identify the template actually. So in this case, we have a label called app, Nginx app, that is defined for this template, and the same name has been given in this selector here. So now when you run this manifest file, the flow of execution is, it will create the deployment object first. And this deployment object is going to deploy some pods, right? The pod definitions are available in the specification under the template. And this template is getting replicated for 3 times. So now the deployment control object, whatever we create, right, it will first use the selector key and get the label. So using the label, it will identify the template. And once it identifies the template, it configures the pod definitions. It configures the replica sets, and then it replicates it for 3 times here. Easy? I will execute this now. I'll be sharing all these documents with you, okay? No worries. So we have API version, kind, metadata, and the label. This label is meant for the deployment object. This label is meant for the template. Difference are there, okay? And it can be different, that's not an issue. And the selector, whatever we use here, this selector is going to use the label that is given in the template. Now let me save this file. And what next? Let's create this now. So once the file is ready, you are going to use the same kubectl create command to create this. Kubectl create -f followed by the file name. And once the file is created, hello. Once the file is created, we can able to use verify the list of deployment objects. See here. If you simply say kubectl deploy means it will try to get the list of all the deployment objects in the machine. But if I want to apply some filter, I can use the label name -l followed by the label. So I can able to get only the object that is matching with the label. So now if you noticed here, we have created deployment object like Nginx deploy, which is having 3 replicas, and all 3 replicas are available and up and running now. So whenever we create any deployment object, it creates deploy object, and it create names, what is it called, replica sets, and then pods. Okay, so these are 3 components created as part of this manifest file. So if you want to get the list of replica sets, we can able to use this command, kubectl get replica set. Replica set means it helps to ensure a specific number of pods are up and running at any point of time. I repeat, replica sets are used to a specific number of pods at any point of time. That is the basic difference here. So used to run a specific number of pods at any point of time. So if you want to get the list of replica sets, you can see based upon the deployment controller object name, it has created one replica set. And this replica set is used to ensure 3 number of pods should be up and running. That's what we gave replicas, right? Replicas is 3. Remember, like this, we can able to get the pod list also. Like if I say kubectl get pods. See, now you can able to understand the 3 copies of pods are up and running. The 3 copies of pods are up and running now. So if you want to know in which node it is running, you can able to use a filter -o void. So we have 3 copies of pod, and out of that 2 copies are running in worker node 2 and 1 is running in worker node 1. So this is how it just distributes the workload. Depends upon the healthy status of the node, it will try to distribute the workload in all the available nodes, depends upon replicas. So now point here is my web application, whatever running inside this pod, it is distributed in more than one worker node.
Would you please recall that command, kubectl get pod? I mean, not pods, just pod, and the name of the pod. So in that case, we don't give pods, right? If we want to run this, I mean, get the list of the specific pod.
Yeah, that's right.
That's confusing, I think.
No, what's the confusion here?
I mean, we used to execute this command kubectl get pods, and sometimes, if we miss s in this pods, then it will not give us the specific pod if we run it.
No, that's not an issue. So if you want to get the list of pods based upon the name, you can able to give a name of a pod here. Or you can able to give some label here. But now I just have only 2 pods. So I just gave a list, complete list. So we can able to see the list of pods that is deployed using your deployment control object, as well as a separate pod whatever we created earlier. Right.
And now if let's say this IP address, that assigned to the pod, and that pod gets killed or damaged, so
Yeah.
replica set would create the new pod, and this IP would be changed in that range that we defined earlier in the master.
Yes. So whenever we face any issue in this pod, if the pod got deleted or corrupted, your replica set, whatever we have, right? What is the replica set actually? It helps to ensure high availability of that pod. It just specific number of pods will be up and running. So immediately try to create a new pod with the same configuration, whatever we have in our deployment controller. And that pod will be allocated the new IP address. Right?
Here the question comes like on worker node 1 and worker node 2. So I just want to know, like, this replica set would create those replicas of the pods on both the nodes, or because we are running from a master, right? Executing this command.
See, try to understand the workflow. Using your API server, this request will be processed, right? When your manifest file is ready, your API server is responsible to process manifest file, right? And it just maintains the information of your pods, everything under the etc directory, and it is the responsibility of the scheduler to identify the healthy worker node. Correct? It is not about the replicas. Replicas, all these things are managed by a controller object. In a Kubernetes master, we have a controller object. Remember the architecture diagram. So that control object is going to take care of your replica sets and all. But the point here is the actual worker node identification will be done by the scheduler. So if you have 3 replicas of pod, there is no problem. Even if you have 100 replicas of pod also, there's not an issue. But the allocation of the pod in the target node, it is purely done by the scheduler. Got it? So that matters. Your replica set is nowhere related to that. Replica set is just to ensure the specific number of pods up and running, that's all. In which node it is scheduled, it is taken care by the scheduler.
When we created manifest file, I mean initially before so in that case, like when we create the pod, I still get confused. Can you go back to manifest file, please, for the replica set? Yeah, so here I'm talking about. So let's say if we run this file, and now this is something like the pod deployment, right? So once we deploy this pod, so in that case, a kubelet would, scheduler would decide which node is healthy, and then kubelet would deploy those pod on this node, right?
Yeah.
Okay.
Yeah, that's right.
Okay.
So scheduler identifies the target node, and on the target node, your API server will interact and share all these details, and the kubelet which is running the target node is responsible to deploy this. Right. So now that we can see the objects, whatever we created, 3 replicas of pods up and running. And if you want, you can able to give some describe command for this deployment control object. So if you simply say kubectl describe deploy, you can able to see name of the object and the namespace in which namespace is running and the label of that object. And very important thing is the strategy, the deployment strategy. Okay. So whenever we talk about deployment control object, the deployment strategy is going to decide the strategy of deployments. Like without downtime, how we can able to deploy the objects, that will be done by the, that will be identified by the deployment strategies. So by default, we use a rolling update as a deployment strategy. We have many types like blue-green deployments, canary, a lot of things are there, recreate, a lot of things are there. But out of the default one is rolling update. So rolling update means, let's say I told you there is one point here. Deployment control object used to upgrade. So in this case, if you noticed, I have my Nginx image that is running with 1.7.9. Okay. So I'll give you one scenario. Consider I have a web application v1.0.war file. So this is a artifact which I built, and I just create an image out of it. My web app v1.0. This is the image I created, and I just publish it to Docker Hub. Docker Hub. So once it is published to Docker Hub, this can be deployed into the Kubernetes cluster by writing the deployment control object. Assume that instead of Nginx, we are using that application image, and got deployed. And it has 3 replicas of pods up and running for this. Now, at any point of time, developer can able to create a new version of it, right? They can able to upgrade their war file, no? Possible, right? Yes or no? So they can able to create any number of versions here, and it will get updated in their repository as well as in the Docker Hub registry. So now my initial version of pods are running in version 1.0, and whenever I go for upgrade, the latest image has to be updated in all the replicas. That is a very important thing. I have nearly 3 replicas up and running. So in all the 3 replicas, I have to update the image. So how it is possible? How it is possible? For that only we are going to actually use our deployment control object. So we have something called deployment object, something called update as well as the rolling update. So rolling update means at any point of time you can able to, it allows you to set the image to a new version. If you look at this example, initially it is running in version 1.7.9 and I want to upgrade it to 1.91. Okay. From the version 1.7.9, I want to upgrade to 1.91 means we can able to quickly upgrade by using this command, kubectl set image command. It's possible. If it is successful, then it's fine. What if this new version is not working as expected? What we'll do? If the latest version is not working as expected, we have to revert the changes, right? We have to undo the changes. So for that, we have a command called kubectl rollout undo. So this kubectl rollout undo command will undo changes. What are changes you did here? It will be reverted. It will go back to the previous version. So how this deployment happens? It's ultimately a process of deploying the new image, right? Whether it's upgrade or fresh installation or whatever it is, it's just a process of deployment. So how the deployment happens means by using the strategy called rolling update strategy. So rolling update means consider you have 3 copies of pod, like pod 1, 2, and 3. So if all 3 copies of pods are running in version 1.7.9 and you want to upgrade it to 1.9.1 or 9.1, assume it. So whenever I go for upgrade, right, I'm not just going to upgrade a single copy of pod, I have to upgrade all the copies of pod. So all these copies of pod, how it is going to get updated? Whether you're going to down all these things and update it once for all, or you're going to update one after the other. That matters. So all of a sudden, if you down all these pods and try to create a new pod with the latest version, definitely it creates some downtime, correct? So no. So there is
Yes.
not a recommended approach when it comes to your Kubernetes-based deployment. That's the reason by default they use rolling update. Rolling update means first it will try to pick up one copy of pod and it will update the latest version in that pod version. If it is successfully deployed and if the new version is successfully up and running, then only it will pick up the next copy and try to upgrade it. If the first upgrade itself is, if it failed, it won't go for further updates. So that's what we call as a rolling update means. So with this, while we are working on the current version, your remaining 2 versions will be available for your access. So which will not have any downtime. So even if you have 100 copies of pod, your rolling update will go one after the other. It takes some time, but still, in order to ensure high availability of application, it's not an issue. But taking time means it's not like, hours and all. Just within a minute is going to complete everything. Understood? So that is what we're going to perform now. So first I'll show you a demo, how to set up an image, new image. Initially it is running in 1.7.9. Now I want to upgrade it to 1.91. So how to upgrade it? Got it? And if anything goes wrong, how to undo the changes and how to redeploy it. Clear? Shall we? Okay, let me execute this command. This record parameter is optional. Okay, if you want, you can use it. Otherwise, you can ignore it. Maybe in the next version of Kubernetes, it won't be available. What is the purpose of record means? It is just to record each and every activity of your deployments. It is completely optional. Just use this. So now what I'm going to do here is,
Can you explain this command parameters? I mean, what we are going to execute? What set image deploy, then Nginx deploy, Nginx container. I mean, one by one.
see, you know what is deployment object we created, no?
That's true.
This is the deployment object we created, right? And this deployment object by default running in Nginx 1.7.9 version, correct?
Yes.
And the name of the container is Nginx container. In this container only, this image is getting deployed, right? So now my intention is I want to change this version number 1.79 to 1.9.1. That's a requirement. So for that, we have a command, kubectl set image. This is a command which is used to set a new image version to this deployment controller object in this container. Easy.
Yes.
So now by default it is running in 1.7.9. Now I want to make it to 1.9.1. kubectl set image deploy, Nginx deploy, container name is Nginx container followed by the image along with the tag 1.9.1, and record is optional for recording the changes. See, now the image has been updated. Image has been updated. So if you want, you can able to verify the image. Let's say kubectl describe command. So if you see here, if I use kubectl describe command for the deployment object, it is pointing to the latest image whatever is sent here. Correct? Earlier it was showing 1.7.9, now it is 1.91. Actually, it should be 1.9.1, but accidentally it is something like 1.91. Correct. Deployment object has been successfully modified. But the point is, if you check the status of the deployment, kubectl rollout status. What are the deployments I did now? I just want to check the status of deployment, and it's, you can see it's still in waiting stage. It does not take this much time. It is trying to pick up the very first copy of the image pod and try to deploy it. Clear? But here it is taking more time. Maybe there is some issue in the deployment. Just give Control C to come out of the command, and you can able to verify the list of pods now. kubectl get pods. So now if you noticed, it is trying to deploy a new image. Okay, with by creating a new pod, but it is saying like image pullback of error. That means the deployment, whatever we did now, it has updated the image name in the deployment object, but based upon the image, when it tried to create a new pod, it is unable to create. So what does image pullback of error means? It is trying to pull some image from the Docker registry, but the image is not found. That's what the issue. So it means the actual image I want to use is 1.9.1, but I just gave 1.91. So definitely this image version is not available in Docker Hub. That's why your deployment is failing now. So once the deployment failed, what we'll do? We have to immediately roll back this. I want to go back to the previous version. So to do that, we have a command called kubectl rollout undo. Kubectl rollout undo command. Kubectl rollout undo deployment and name of the deployment object, whatever you created. See, rollout is completed. And again, if you want to check the status of this rollout action, you can check the status, and now it is successfully rolled out. Can you see this? Earlier it was waiting. Correct. I gave Control C and came out of that command. But now as soon as I give rollback, it is successfully rolled out. So now if you give a describe command, and you should be able to see the object, it went back to the previous version. And similarly, if I try to get the list of pods, all the 3 pods are up and running. So the pods which was struggling to create, it is completely removed. All these things are running with the previous image actually. So this is what is scenario in real-time environment. Whenever we try to deploy any new version of the pod, if it fails, how we can able to quickly roll back without any downtime. That is a very important point here. It is not like after making your system down and we are doing all these things, not like that. You don't need any deployment window here. On the go, you can able to do a deployment. If anything goes wrong also, you can able to quickly revert the changes. So for all these things, you need to have a dedicated deployment window and create a downtime and all. It's not required. Hope you're getting a point now. How to use deployment control object to deploy the images and how to upgrade the image. And if anything goes wrong, how we can able to quickly bounce back. So now if you are revert changes, if you want to give, you can able to give a valid image here, like Nginx 9.1.9 I can give now. kubectl set image followed by the name of deployment object and specify the container name and the image. Now it is 1.9.1, which is exactly the same. So once it is done, I can get the status of the image deployment. See here, the rollout status for this is waiting for now, and it will just keep on trying to update one after the other. See, it is progressing. It has updated one image and is picking up second image, second pod, and it just keep on deploying it. It's done. So after deploying it, just delete all the unwanted pods. And now if you get the list of pods, you should be able to see it's all up and running. And if you see the describe object, you can able to see it is deployed with latest version 1.9.1. Easy. So are you getting a point? So this is the way we'll be doing a deployment in Kubernetes. So developer, whenever they share the manifest file, for the very first time, they'll create an object. Then after, once the image is ready, we can quickly update the image by using the kubectl command. No need to create a separate manifest file for this. It's not required.
In real-time scenario, how we we don't know like specific version, right? The latest version. So we just simply put that Nginx and call on latest. In that
I'm
case,
not
it works.
talking about the Nginx here. It can be any application image, right? See.
Yeah, any application, but
This is what it is. Consider this is one of my web application. It can be from a banking domain or telecom, whatever it is. Whenever I create a build an application, I create a WAR file. Based upon the latest WAR file, I create a new image, right?
yes.
That image has been published to Docker Hub. That image name only I'll be giving in my upgrade. Easy?
Yes.
Fine. So now once it is done, okay, your deployment is successful and you can able to see the objects up and running. The pods, whatever you created is up and running. So in a normal workflow, the 3 replicas are sufficient. But what if there is a huge traffic? Okay, like even if you take any online reservation systems or online ticket booking system, or even your e-commerce portal like Amazon, whenever they introduce any new offer or Tarkal ticket booking period and all, right? At that particular moment, there'll be huge traffic, more number of users unexpectedly they can able to access their applications, right? So in such scenario, if you think your 3 replicas are sufficient means then it's fine. But what if the 3 replicas are not sufficient? How we can quickly scale up? For that we use this command kubectl scale deployment. See, kubectl scale deployment nginx deploy followed by replicas as 5. See, within few seconds, not even few seconds, okay, within a second, just create a new replica of it. Initially it was running with 3, now it is 5. Like this, as per need, you can able to create any number of replicas. See, I created 15 now. It is creating container out of it. See, it's all up and running. So 15 replicas of my pods up and running. So, but I have only 2 worker nodes. So if I say hyphen O void, I can able to see out of 15, few are running in worker node 1 and few are running in worker node 2. Like this depends upon the health status of the worker node. Your scheduler will equally distribute your workload. Easy. If you have few more worker nodes, again it will get shared. Like 15 means it can be, if you have 3 worker nodes, 5 plus 5 plus 5, like that it equally distributes the workloads. Easy. So this is at the high traffic. But once the traffic is less, you don't need to consume this much resources, right? So you can quickly reduce it. So if you want, you can quickly bring it down to 2 also. Because there's no usage, I can simply reduce the traffic here. So now if you see the pods, it is just going to retain only 2 copies of pod and all other things are getting terminated automatically. See, it's all terminating and it's done. Finally, it is having only 2 copies.
Sai, one question. Even though we increase the replica, right? So, but that worker node will be like giving response based on the like capacity, right? Configuration of that particular.
Yeah, that's what it's all matters. Okay, it's all decided at the initial architecture type. So the worker node, what is the configuration of worker node? Currently, we're using just T2 micro, right? But in real time, it will be like a T2 medium or large. And at any point of time, if that node is not sufficient, we can have one more node. Correct. It all depends.
We also have a limit of creating replicas, right? For that particular.
No, not
Again-
like that.
Okay. Again, it will be based on the application, like.
No, it's not like that. It is completely independent. Okay, see, we can able to create the replicas at the pod level, or if you want, you can able to scale up your worker nodes also. Let's say to run the 15 copies of pod, if the worker nodes are not sufficient, I can add 2 more worker nodes. There's no harm in that, right? So scale up or scale down can be done at the pod level as well as at the node level. Easy. Please try to understand, okay, these are all at the deployment perspective. When you deploy an application, ultimately, I want to ensure that a copy of application should be up and running at any point of time. Whether you're going for upgrade or a downgrade, or whether you want to, if you are working on any production issues, whether if your deployment is failed, whatever scenario, my application should be up and running. That's what the scenario here, right? It should not create even a small downtime. So without downtime, how can you deploy your applications? That's what the Kubernetes is going to teach you here. Easy. So once the process is completed, okay, if you think the application is completely deployed successfully and is executed successfully, if you no longer need it, means you can able to delete all the objects. Object means, as I said, whenever you talk about deployment, it creates a deployment object, replica set, and the pods. Okay. And if you want to delete all these objects, you can simply delete by using a file name. So kubectl delete followed by the file name, which will delete all the objects associated to that file. So you don't need to manually go and delete each and everything. Like if you have 15 pods, means you don't need to delete each and every pod one by one. It's not required. Even if you delete a pod also, you'll recreate it. That's what the property of your cluster deployed object, right? If pod is down, automatically creates a new pod. So there is no point in deleting a pod here. It is always recommended to delete the master file, which is responsible to create the object. Easy. So clear to all? So this is all about your deployment control object. It's a very important interview question also. Deployment control object is used to deploy the applications, which creates the replica sets to ensure a specific number of pods up and running, as well as it helps to quickly upgrade or downgrade or roll back, upgrade or roll back the changes. And also it also helps to quickly auto scale up and scale down. Easy. Any question? Hello, are we good with this, all of you?
Yes. I have a query with, the user requests. Let's say if we get 1,000 or 1,500 user requests in a day, and then we have 3 nodes, right? let's say 2 nodes, and each node is having 3 replica set. I mean 3 pod replica set of the pods. So now, if the user requests are increasing, in that case, these pods would be, automatically created as per the node basis, or we have to create one more node and then define.
See, that is what the role of administrator, right? As a Kubernetes administrator, upfront you should know the workload. What is the application? What is the frequency of deployments? Right? What is the volume of the application? Everything you should know as an administrator. You should have all these details upfront. Based upon that, only your cluster architecture will be defined. So if you can recollect our last day session, I was talking about the architecture of Kubernetes, right? So there I gave you one quick example. Like whenever we talk about the architecture, your Kubernetes can have more than one worker nodes. Master can be attached to more than worker nodes, or in real-time environment, we'll be having more than one cluster also. Correct? Cluster is nothing but the logical identity of your worker nodes, group of worker nodes.
Yeah,
So,
that's true.
Depends upon the requirement, you can able to add any number of nodes here. Let's say these 3 nodes are not sufficient, means you should be able to quickly add a node to the master. It can be done dynamically or it can be done statically. Depends upon the frequency of deployments.
Yeah, I meant only dynamically, because we
Yes,
never know, right?
it's
How
possible.
when the
It is
user
possible.
requests.
It is
Okay.
possible. That is the reason we learned about some configuration management tool. Your server should be up and running. You should have an image of that server. So using that image, you can quickly create a new server and it can be attached to your nodes directly. It's possible.
Okay.
So that is what the scaling means.
How we can do that with, I mean, after creating the cluster, how we can increase this port? I mean, manually, or it would be service that would do it.
Node or what you are saying?
I mean, after as an admin, Kubernetes administrator has created a cluster, right? Kubernetes cluster. Now, as per the user request, predefined user request. Now, let's say if the user requests are increasing, so in that case, we have some. I mean, we have to define something in a manifest file that would create the nodes automatically.
No, not like that. Not like that. See, it is done by 2 levels. One is if you are using a managed services means there you have a capability to auto scale. Okay, in a managed service, we have auto scaling capability on the VM level. So we can able to add any number of nodes to your cluster. Based upon default configuration, takes care of it. But if it is open source means it is our responsibility to write some script to automate that. Like if you want to configure a node, you know what are things to be done, right? You have to run all these commands there in the node, right? Hope you remember.
Yes, on both. Yeah, on
Yes.
worker nodes.
So whenever you try to add any node, that node should have all these things to be installed and configured. So if you want to dynamically do this, you can't do it manually. So what we do, we just convert everything as a script. Okay, if you want to give a logic here. So using Terraform, you launch the instance. And then you can run all these scripts as a startup task, or through Ansible, you can able to run it in your target machine. And your node is ready. And automatically through your Ansible itself, you can able to attach this node to your master by using a kubevarium join command. It's possible.
Okay, so that would be provisioned by this Terraform, right?
Yeah, using Terraform, that's what we can able to integrate all those tools. Yeah,
Yeah,
Terraform
okay.
and Ansible. You can dynamically create the servers.
Okay. I mean, I just was surprised, like in this manifest file, if we have something that would automatically, create the replicas as per the demanding request.
If it is a managed service means we have the capability. I'm telling you, right?
Yeah.
But if it is open source, then we have to map that image. We have to identify the AMI of that. Normally, we never create these servers manually. The servers, whatever we create, right? The Kubernetes master worker node, whatever we have this configuration, all
Yes.
these things are considered a startup task while launching instance.
Okay.
Hope you are aware of the startup task, right? So when I start the server, when I launch a server, I want to run some task as a default or a startup task. Like for example, when you start your VM, your Jenkins is automatically getting started, right? If you install
Yes.
Jenkins, when you stop and restart your server, Your Jenkins also starts automatically. So how it is happening means internally there is a script that is running to enable your Jenkins to start automatically, right? So that is how like that we can able to create some startup service. So that script will automatically configure all those things when you launch your instance. And it will automatically join that instance to your master. So that level of automation or scripting should be done by the administrator, Kubernetes administrator, if you're using open source Kubernetes. But if it is a managed service, then there is no issues like that. While giving your cluster definition itself, will be giving all these parameters. What is the maximum limit and what is the minimum limit? Whenever the scaling is required, how dynamically I can able to scale up, how many servers I can able to add. Everything can be given at the initial configuration itself. With that, it automatically takes care. That's what the difference, basic difference here between managed service and open source.
Sai, we have created that deployment index. Right? What about that expose? We have to do it for all the three all the three pods which we
No,
have
not for all
created.
three pods. You can create a service. It is not expose actually. It is a service. Basically, the expose command, whatever you use here, it is ad hoc command to create a service, node port service, right?
Okay.
So this node port service is created for the pod actually, because we are considering only pod. But here, the pods, whatever we create in deployment, it is created by the deployment control object. So you can able to expose the deployment control object directly. It is applicable for all the pods.
Okay, in the place of pod, we can be using that
Deployment.
object name itself.
Yes, deployment object name. I'll show you tomorrow. I'll show you while working on it. So tomorrow I'll just show you how to create a deployment control object and a service that can be associated deployment object. Okay. Fine. So here, while talking about the services, we discussed about node port service, right? Node port service is used to expose your port to internet, and cluster IP is meant for internal process. Like whenever we have a pod, if you want to maintain the communication within the network, like consider I have a 3-tier application. In the 3-tier application, I have front-end pod, application pod, and then back-end pod. So this front-end pod is something used to interact with the end user, right? Front-end pod is used to interact with the end user. Similarly, the application logic and the back-end pod, we can't expose to end user, right? Is I following or not? Consider this is my front-end pod, my application pod, and then a back-end pod. So whenever we talk about the front-end pod, this front-end pod is having some user interface. So developers or end users can able to interact to my application using the front-end pod, and they'll be giving some inputs here. So this inputs will be sent to the application logic, received by application logic, that will do some sort of validation. Once the validation is completed, depends upon request, it will try to update it in the database, right? Once database is updated, database is going to send some response that will be received by the application logic, and that response will be again sent to the front end to share it with the end users. So this is what the flow of your 3-tier application architecture. Now in this case, consider that we have 3 pods up and running. Out of 3 pods, which pod should be exposed to internet?
Front-end pod
Front-end pod.
is
Only
the
front-end
user
pod.
interface.
Yeah, only front-end pod can be exposed to internet. We can't allow the end users to directly access the application or database, right? That can be handled only through front-end based upon the request. So for this front-end pod, we'll be creating a node port service. And how the front-end pod and application pods are communicating between each other means by using the cluster IP service. So between your front-end pod and application logic, there will be a service called cluster IP service. And here also will be a cluster IP service. So through that service, your pods will get communicated internally. using the pod IP address or the port number, whatever it is associated to the cluster IP. Is it clear?
For
So
this cluster IP, there would be some authentication, right?
no, not necessary.
I mean, for database, like how can we give
That is taken
anyone?
by the application logic, right? Application, they have a script, they have a query, like a select query or retrieve query, whatever it is, they have a
That
query.
would be,
That will
yeah.
be taken by the application logic.
Okay.
So that's what the basic property of a 3-tier architecture, right? Database server is completely different. It is just for running their database, right? Whenever application try to query that, through that SQL query, they just have all their credentials, whatever they want to handle it.
No, I mean, with cluster IP, if this front end application logic and back end would communicate each other. So in that case, like person would be accessing must be authenticated with this 3-tier, or some the person having the rights of the cluster IP of the node who can access this through the cluster IP.
No, I'm not getting a point. What you're trying to say here, like
Let's say we talk about this front end and application logic, right? So if these two ports are connected through cluster IP, now anyone like outside of the world cannot be able to access it. So now the person inside the organization might have these rights to access this, right? I mean, some level of authentication.
okay.
So that was I'm talking about. I mean, is there some setup for the authentication, or
See, first try to understand the workflow here. We are not talking about the resources. It's all just the pod and the service. If you're talking about resource means you have to start from the scratch, the namespace level. Like whenever you create any pod, the pods are getting created in the default namespace, right? Hope you've seen now.
yes, in
So it
default?
means as a user, we are not authorized to create any pod in the system namespace under Cube system. Because in Cube system, all the system pods are getting deployed. Correct. So that is how the no access will be defined. So we have something called RBAC, that is role-based access control. So through that, each and every resource you create, it will be having its own access level. So what is the role? What is the access? Everything. It will be having some service account level or group account level or user ID level. It just maintains it. But the point here is, when it comes to 3-tier application architecture, the application, whatever the end user wants to access. Let's say as the end user, you are trying to access gmail.com. Means you'll be getting the front end page, right? You'll be giving your inputs here. Are you directly accessing, running that application? No. It's all the application architecture, the 3-tier architecture that is designed in such a way that whenever the user gives the input and if you click on the button, automatically the response, whatever you need, it should be processed through the application. And the application will receive the request, it will validate the request, and automatically the request, if it is managed through database, means it will give a call to database server, that particular pod, and it will get a response from the database and it will process the data. So here, where is the manual intervention? How can you say that other user can able to interact here?
I mean, each of this node having different IP address, right?
It is not a node, actually, it is a pod.
Sorry, pod. Yeah.
Okay, each and every pod has its own IP address. That's fine.
Yeah.
But whenever we talk about a pod, as I said, pod is not a permanent entity. It can delete at any point of time, right? So if I use a pod IP address, I can't rely on the pod IP address. What if the pod got deleted? This pod got deleted. So I can't rely on the pod IP. So to overcome that only, I use a cluster IP. Cluster IP is something constant IP address that is internally maintained. So whenever the front-end pod wants to communicate to this backend pod, it never refers the pod IP address. It uses the cluster IP address to refer it. So at one point in time, if this pod got deleted, what will happen? Your controller manager will create a new pod of the same configuration. That's what you've seen now, right?
Yes.
So when it
Yes.
creates a new pod with the same configuration, the pod IP address will change for sure, but the cluster IP will not change. The pod, whatever it created newly, it will be mapped to the cluster IP. So at any point of time, the cluster IP also will be remains there. which helps to continuously interact with the pods internally. You understand the flow now?
Yes.
Got
It's
it.
clear
So
now.
here it is nowhere related to your pod IP address or the nodes. It is completely managed internally for the conversation between the pods. And another one important thing is about the node port is the node port, whatever we have created, right? It is meant for a specific service. If you have one microservice, means for that particular microservice, for deployment of the microservice, we can able to use one node port service. That's all. One-to-one mapping. That's all we can do. Let's say I have created one deployment controller object, which is having 3 replicas of pod. So for the deployment controller object, I can create one service. Okay. Similarly, if I have another deployment controller object, means I can't use the same service there. That will be done with a different service. So like this, for each and every service in your application should be created with a separate node port. That is one point. Second point is, let's say I have replicas. In this case, I have a replicas of pod. So these pods are exposed in more than one worker node, right? Guys, you're following this, right? These pods are distributed more than one worker node. So assume that I want to access the application running inside the pod. How to access it? I'll be using external IP address of the machine along with the node port. Correct? Similarly, if I want to access the application running in this worker node 1, I'll be using the external IP address of the machine and node port. So node port will be same, but it uses 2 different external IP address because the pods are distributed more than one worker node here. Are you getting your point? So whenever the pod is distributed more than one worker node, if you want to access the pod, you'll be using the external IP address of the machine. If there are 100 worker nodes, means you'll be using 100 external IP addresses. So practically we can't assign 100 IP address for a specific application, right? One application should have one IP address, one DNS, like gmail.com in gmail.com. I can't have more than one URL for this Gmail application, right? But when your pod is distributed more than worker node, it demands more than one external IP address. So how to nullify that? For that only we use a load balancer service. So let me clear the screen. So consider, listen please, consider I have a worker node 1, worker node 2, and worker node 3. So these are node 1, node 2, and node 3. So in this node 1, I have a pod up and running, and the same copy of pod are distributed more than one worker node. All these things are same copies of pod, okay? It is not different pods, replicas of pod, you can consider that. So even if you have 3 copies of pod up and running, for all these pods, I can have only one node port service, correct? I can have only one node port service associated to this pod. So that node port service can be something like this. So whenever we talk about node port service, it creates one unique node port starting from range 30,000. And using the node port service only, I can able to access my application. So here I just showed you. Once a node port is created, using the external IP address of the machine and the port number, we can able to access the application. Now, the applications are distributed in more than one worker node, node 1, 2, and 3. So how many IP addresses you need here? How many external IP addresses you will be using here? If you want to expose the application to internet, how many external IP addresses you need here? So you can use the external IP address of the node 1 followed by the port number. Similarly, external IP address node 2 and node port. Like that, this application will be using 3 different external IP address to access the application, right? Are you understand scenario now?
Yes.
Is it clear to everyone?
Yeah.
So whenever the pods are distributed more than one worker node, and if you create a node port service for this particular pod, we need the external IP address of all the nodes to access the application. But in real-time environment, practically it is not possible. In non-prod also we can able to manage, because non-prod environment is just an internal testing purpose. We can manage it. But in real-time environment, once a product goes to production environment, we can't share 3 IP address to the end user, right? So what we do means, on top of node port service, we introduce one service called load balancer service. So this load balancer service also will be having one IP address. Got it? So this IP address will be mapped to your DNS, domain name service. Clear? And this will be given to the end users who want access through internet. Now, when end user enters this DNS or IP address on their browser, first they're hitting the load balancer. So the load balancer IP address is configured based upon node port service, which is mapped to the pods internally, right? So like this, we can able to manage only one IP address to access the application, and that application internally routes through the node port services. Okay, there are a lot of too complex processes are there involved if it is comes to the networking and all. But on a high level, try to understand the purpose of the load balancer service. It is just to reduce the number of external IP addresses, and it routes the request to your application using a single IP. And another important capability here is we can able to completely reduce the number of node services node port, because if you have 100 services here, I can't create 100 load balancers, because load balancer is something costly entity. Load balancer is not part of Kubernetes. If you're talking about a pod, means pod is a Kubernetes object. Deployment control object is a Kubernetes object, but load balancer is not a Kubernetes object. It is something we are going to procure from the service provider. Okay, we have something called network load balancer, application load balancer. That is something procured from the service provider, which is a costly entity. Got it? So in order to reduce the cost of load balancer, in order to reduce the number of load balancer, we use another controller called ingress controller. Like this, a lot of topics involved. Tomorrow, if you get an opportunity, you can able to specialize on all those things. So, and another important thing is about the namespace. Names also plays a very important role here. If you can see this, the namespace. So what I said about namespace here, namespace is a logical partition of Kubernetes. So in which situation will be using this namespace means, let's say, for example, consider I have an cluster. This is a cluster, and this is a master node. And this cluster will be having a number of worker nodes, right? Hope you know about it. Cluster is a collection of worker nodes. So this is worker node 1, 2, 3, 4, 5, and 6. Okay. So in real-time environment, we'll be having the Kubernetes infrastructure for both non-prod and prod. We'll be having 2 different entities. We'll be maintaining a dedicated Kubernetes platform for production workload. But in non-prod, we can have only one platform. Like, for example, consider this is a cluster which is having some worker nodes. Now, I want to do some sort of testing. So for the purpose of testing, what we do, we introduce some test environments, right? Like QA environment, UAT, and then like this, we have a pre-prod kind of thing, right? So for each and every environment, I can't invest and create a new cluster, because cluster means it is a virtual machine, collection of virtual machines. Each and every virtual machine is a costly entity. So for each and every environment, I can't invest, but I already have nearly 6 VMs available. So what I can do means I'm going to create a logical partitioning of this cluster by using the namespace. So whenever you create any namespace that is applicable at the cluster level. So let's say I'm going to create one namespace, another namespace. These are logical. Let this namespace for my QA testing, and this is for my UAT testing. So let's say whenever I try to deploy anything in QA environment, I'll be pointing to my QA namespace. So QA namespace means it's just a logical name or work area where your pods will get deployed. It is also going to share all the worker nodes, everything, but in which work node is going to allocate, that is not sure, but it will be restricted to the namespace. Clear? Similarly, we can have a dedicated namespace for developers also. Dev namespace also we can have. It's possible. So in your Kubernetes environment itself, if you noticed, kubectl get namespace. See, we have these many namespaces available here. So if you want to create any new namespace, there is a quick command, kubectl create namespace followed by namespace dev. I want to create a dev namespace. So dev namespace will be created. Similarly, if you want to create a QA, just create a QA namespace. Or if you want to create a UAT, create a UAT namespace. That's it. And if you get the list of namespaces here, you can able to see the dev, QA, and UAT namespaces are created for us. Easy. Is it clear to all? So like this, we can able to create namespaces at any point of time. And once the namespaces are ready, if you want to use the namespace for deployment. So let's say in my case, I want to deploy one pod in one specific namespace. As a developer, I want to use my dev namespace to deploy my pod. So let me show you that example here. I think already we have an Nginx pod namespace available here. A pod is available, right? So if I say kubectl get pods, I can able to see these pods are running in default namespace. All can you see this? Pods, whatever we have deployed, it's all running in default namespace. And all other pods are running in its own system namespace and front end namespaces. So like this, now I want to create a pod to deploy it in dev namespace. So for what I can do means, I can simply refer the pod definition. So let me use the same pod definition. Let it be pod 1. I'm creating a new file out of it. And I'm going to edit the file now. So now in this file, I'm going to create a new pod. The pod name can be same. That's not an issue because we are going to deploy it in different namespace. Within a namespace only, the pod name should be unique. But the same pod can be deployed in more than one namespace. It's possible. And the namespace you should give here. Colon dev. Means I want to create a pod. If you want to uniquely identify, just give a name here. It's not an issue. I want to create a pod and I want to deploy the pod in dev namespace. So just in the metadata, immediately after the name, specify the namespace where you want to deploy it. The label also is optional, but if you want to be specific namespace, just use this keyword here. And save this. That's it. Now if you can say kubectl create -f followed by the file name. It has create one pod. And if you see the list of pod, what's the name of pod we created here? Remember?
Nginx pod 1.
Pod 1 in dev namespace. Right? So now let me get the list of pods. kubectl get pods. Can you able to see it here? No. Why? Because it is trying to retrieve from default namespace. If you want, you can able to get it from all. So if you try to apply filter based on namespace level, you can able to see the dev namespace that is running one pod here. Easy. Is it clear? Are we good with this, all of you?
Yeah, yeah.
Yes.
Guys?
Yes.
Okay. That is about the namespaces. Okay. So in a real-time environment also, we never encourage people to create anything on default namespace. We'll be creating a dedicated namespace for the team or at the environment level. Each and every team, they might expect their own namespace to deploy their pods. We'll be allocating to them. Right. So these are things you should understand when it comes to your Kubernetes as far as your course content is concerned. But I'll tell you tomorrow, if you want to specialize in any of the DevOps tools, I strongly recommend a focus on Kubernetes and Docker related things. Okay. Like if you're preparing for any external certifications or something, focus on Kubernetes because it's a very huge area where you can able to explore more and do a lot of things when it comes to deployment, especially for your microservice-based workload. All right. So you should know what is the architecture, what are the components we have, and how to create deployment control objects, and what are the features we have in deployment control objects. So next topic, I will talk about something, fundamentals of your monitoring tools. Because upon deployment, we'll be focusing on monitoring, right? So we'll talk about the fundamentals of monitoring. And in the next session, it will be like complete demo session. I'll be showing you end-to-end pipeline, like starting from application build, how to create a application build, how to perform the Docker image creation, and how to deploy to Kubernetes cluster by integrating all the things in the Jenkins pipeline and show you a demo. It will be like a complete package for you to implement the things. Is that fine?
Okay.
Right. Yeah, no problem. I can share something on resume preparation also tomorrow. If you need any inputs on resume preparation, I can share the details.
Okay, then. And also one thing, if joining that group, it will be good for us. So if we have any doubt, we can directly communicate with you.
Yeah, I'll check with that. All right. So this is about your Kubernetes. The next thing is we're going to focus on continuous monitoring. So we'll be focusing on Prometheus and Grafana. Shall we? If you want
We
to
take
have
break.
yeah, if you want to have break, you can go ahead. Yeah, no problem. You can continue. How much time you need?
20 minutes.
There's a timer. Okay.
Yes.
All right, then carry on. 20 minutes. Fine.
Yes.
Go ahead.
Yeah. Yes.
Go ahead. So once you're back, then we'll talk about the Prometheus and Grafana.
Sure, Sai.
Hope you'll be back, right? Yeah, hello everyone. Shall we continue now? Hello, guys, I'm audible to all. Hello, I'm audible.
Yes.
So next we are going to talk about continuous monitoring. Okay, so like once the deployment is completed, so we are sure that the Kubernetes can able to ensure the replicas and automate the pod creations whenever it is down, right? So apart from that, on the infrastructure level, okay, so we have to implement some sort of automation or implement some sort of monitoring. So when it comes to the continuous monitoring on DevOps perspective, right? So we'll be monitoring the infrastructure as well as applications. So when it comes to infrastructure monitoring, we'll be monitoring the system's CPU utilization or memory utilization, okay, or sometimes network traffic. All these things can be monitored. Similarly, when it comes to the application level, so how the applications are created, what are the various dependencies we have, and the database, like how the applications are giving a request to database and how much time it is consuming to process a request or a query, and how much the query is optimized, right? Because only the optimized query can able to pull the data right in effective manner, and that too when there are multiple tables are involved in database, or if there are multiple database involved in the transaction, then the query optimization plays a very important role. So all these things can be monitored, effectively monitored with the proper monitoring tools. So here we are going to talk about something on Prometheus and Grafana. Prometheus is a monitoring tool. Like if you talk about Prometheus, means Prometheus is a infrastructure monitoring tool. Okay, and Grafana is just a visualization tool. It is just for visualization. It is just to visualize, create a visualization of the monitoring matrices. So apart from Prometheus and Grafana, there are various products available market. Like we have Datadog, Dynatrace, Splunk, Nagios. A lot of tools available in market, but it's all depends upon the license and the versions. The Prometheus is open source monitoring tool, and in Grafana also we have a community edition as well as enterprise edition. So that matters. So when it comes to your Prometheus, right? We can able to integrate Prometheus in dedicated server and monitor all our infrastructure. Like it can be a dev environment or QA environment, or even if you have any servers dedicated for your DevOps, you can able to monitor it. So whatever the monitoring tool you're going to use, the basic architecture, okay, architecture is very important. So the architecture what I'm going to give here, it is for Prometheus, but it can be common for any monitoring tool in future if you use. Like if you see here, so whenever we talk about monitoring tool, if it is a Prometheus means this is what it is. So we'll be having a dedicated monitoring server. We can have a dedicated monitoring server where we can able to install Prometheus, and we can able to run all the Prometheus related services in that server. And the capability of server is it will be running the Prometheus service continuously, and it will be having its own database. Database means here we are going to use a time series database. Time series database that is responsible to manage your matrices. And what are the servers you want to monitor? Like it can be any of your VM running in your cloud platform or in your virtual on-premise environment, or any of the applications like your Jenkins server, Tomcat server, or your JFrog Artifactory servers, or containers or Kubernetes. So all these things are considered as a target to your Prometheus server. Correct. So all these things are considered as a target to Prometheus server. Clear? So whenever you want to monitor such components in your Prometheus server, you need to install some agents. Correct. So it is something like this. So there is a component called node exporter. Node exporter is an agent that has to be installed in other target machines. And with the help of the node exporter, we can able to pull the data from the target machine continuously. Let's say I have a VM. I want to monitor the CPU utilization of the VM for every 5 minutes or every 10 minutes. Means this node exporter which is installed in the VM, that is the agent that is responsible to pull the matrices for every 15 minutes and send it to the Prometheus server. Correct. So what you need to extract, in which duration you want to extract, all the things will be configured in the Prometheus server in the form of a time series database query. So Prometheus has its own query language like PromQL language. PromQL is a language that helps to query the time series database. So like this, once the metrics are defined, automatically it will be continuously pulling data from the target environment and it will get updated here. Prometheus is just for monitoring. Okay, in real-time environment, we never rely on Prometheus for creating some intuitive dashboards and all, because Prometheus is good in monitoring. But when it comes to the visualization, that means converting the data into a user understandable graphics formats or some charts, Prometheus is not that much helpful. So for that, what we do, we just integrate Grafana with Prometheus. So now this Prometheus, whatever we use, right, it acts as a data source to Grafana. So it means through Prometheus, you'll be pulling the matrices from target environment for every 15 minutes, and that data will be passed to Grafana server for visualization. So not sure how many of you observed the monitoring teams. There is a dedicated team, monitoring team, and a production support team, production monitoring team were there. So it's all completely owned and managed by them. Even be DevOps team will never involve in all this process. Correct. But if you want to monitor any of our Jenkins servers or slave machines or any of our deployment servers, we'll be using the monitoring tools. But at enterprise level, we have a dedicated team who will monitor the entire enterprise level applications and infrastructure, and they'll be responsible for defining some monitoring policies or principles and the process to collect the matrices, adding the servers or nodes to Prometheus server, all the stuff. So now using Grafana, we're just trying to pull the matrices from Prometheus, and just for visualization, we're going to use Grafana here. So apart from this, Prometheus is also capable for alert management. Like basically what is the need for monitoring means there might be some issue happens in the production environment. It might be because of the CPU utilization or memory utilization. So assume that I have a production server which is running my core business application. What if the production server is down due to memory utilization? It's a loss of huge business, right? So what we do means we'll be introducing a monitoring mechanism with some threshold limit. So let's say I have defined a threshold limit of 70%. Okay. So memory utilization 75% or 70%, I just define it here. So as soon as the memory utilization reaches 70%, your Prometheus can able to send some alert. Okay, and that alert can be sent through your Outlook mail alert, or it can be your what do you call that, messenger alert, like it can be a Teams alert or Slack notification, something you can able to give. And not only that, even you can able to in turn invoke your Teams also with some Jenkins jobs to perform. So now once the remit reaches 70%, automatically the alert will be sent to the stakeholders who are responsible for the particular process, and they'll be taking a necessary course of action. So it means before it reaches 100%, we are proactively monitoring the environment and fixing the issue. Because if it reaches 100%, then it's totally down. System will go to down state, right? So just to prevent the downtime only, we are just proactively doing some monitoring and implementing the changes. That was the main objective. So your Prometheus is capable to perform the alert management. It can be in the form of Slack notifications or email notifications, or it can be your webhook notifications. Webhook means like you can able to, let's say for example here, assume that at 75%, I'm getting a notification through my email. So as a user, what I will do to fix a memory issue? I can go and clean up the unwanted files, whatever we have. I'll do a server cleanup, or I can able to add more volumes. I can mount some volumes to my server, right? If it is really critical. So these are two activities I can able to perform. So this activity will be performed manually. Once I get the alert, I need to manually get to the machine and I'll do this manually. But instead of that, if you want, you can able to automate this process. So it depends upon the server type and the application type. You can able to decide whether you want to add more volumes or you want to clean up the volumes. So you can create a Jenkins job that can run on the particular node on the particular machine, and it just clean up all the unwanted files. So like this, now proactively we can able to monitor the target environments and provide the necessary fix before it disturb my entire production server environments. That's what the agenda here. And this principle is common for any monitoring tool you use. Only thing is the licensing and the user interface, the way you implement might be different, but every monitoring tool works on the same principle. Are you getting a point now? Related to monitoring tools, right? So regarding your resume preparation, so no need, it's not required. Yeah, that's right. See, as I said, right, your core DevOps is still Kubernetes. So whatever you learned from the Git, Jenkins, Docker, Kubernetes all plays a very important role. But monitoring and all right, if you are already part of monitoring team, if you know about the production support activities, and if part of monitoring team means you can mention like you worked in this many tools and you automated all these things like that, you can able to showcase yourself. But if you're not part of monitoring team, you no need to mention it in your profile itself. That's what I can say. It's all just for additional information you can able to grab it. Because definitely if you are part of monitoring team, definitely it will be supportive. But people who are from core development background or who are from DevOps background who are not part of monitoring, you don't need to worry about it. And monitoring tool is not a big rocket science and all. Okay. So any tool you use, today you're learning about Prometheus, but in real time, I'm not sure how many of you are going to use Prometheus. Okay. So it depends upon the enterprise level, which tool they're using. The tools are very much intuitive. It's like, software as a service they provide. So all that you should do is you just install in your environment and start using it. So to use a server, use a monitoring tool, what are the parameters required? What is user interface? Everything will be given to you in the form of manuals. You just simply follow that. But only thing is, from DevOps, what we do means we'll be implementing this as a process. Okay, because as a DevOps team, you should collaborate with your monitoring team and understand the process of execution. If there is any automation needed, we can be able to help them with the automation through Jenkins or through any scripting we can able to implement it. Clear? That is what the main process behind your monitoring here. So what I can, as you said, if you're not part of monitoring means, then it's okay. You can ignore it. You don't need to highlight in your profile. Okay. But if you already have a production support or what you call that, a monitoring background, then you can able to add it in your profile for a safer side. Hope you got my point. All right. Now I'll show you how to install Prometheus and Grafana. Configure Prometheus and Grafana. So this is a very important part actually. Okay, like all these things are just like a general information. you should understand how the real-time scenario, how the tools are getting installed and managed in real-time environment. So for this purpose, I'm going to launch one VM. And in that VM, I'm going to download Prometheus. So basically, Prometheus is an open source tool. Okay, it is not having that much executable also. All that we can do is we can download that package and we can able to extract it. And upon extraction, we can able to run it as a service. Package. And upon extraction, all that you can do is you can able to create a service. And once the service is created, you can able to add the node exporters for any reason. Okay. So now what I'm going to do means I'm going to create two server. One is my source, that is where I'm going to install Prometheus. And another thing is target server. So target server where I'm going to download and install the node exporter agent. So if you have these two servers in place, you can able to quickly launch the instances and start the monitoring. And once the Prometheus is done, then I'll show you for Grafana. Okay. So how to install and manage Grafana, we will show you there. So let me get to my AWS instance console here. I'll stop these instances for now. It's not required. I don't want to disturb the existing one because it is being used for some other activities. So let's install Prometheus in a different server. We can have a dedicated server for Prometheus. So let me launch one instance here. Let's go with the base version itself. So Amazon Linux 2 machine, but you can use the previous version. Okay, don't go with the latest one. The latest version of Amazon, they use a Fedora distribution. Okay, latest version of Fedora distribution. Previous version is we can able to make use of it. So now, while launching instance, leave all the parameters. Let it be T2 micro and the key pair, and leave all the parameters as default. No problem. So let me launch two instances here. Okay. So launching this. Yes, it's done. So now so out of two, we can make any one of this as a monitoring server. And this can be my target server. Target can be anything. Okay. Right. So now let me log into my, what happened to this? Okay. So now let's get into this monitoring server. What happened? Okay, it's a AWS EC2 instance, right? So it's not Ubuntu. For EC2 instance is EC2-user. Okay, so now that we are connected to our AWS instance, and I yum, let me clear the screen. Yum update. Okay, so all packages up to date. So this is my monitoring server. Similarly, let me log into my target server for that, which I want to monitor or display some content. Okay. So this target server, it can be anything. Okay, even if you have any existing server like Jenkins server or any other server, if you already have, you can use the same. No need to recreate anything. So now let's get into this monitoring server, and we need to install Prometheus. Okay, for the installation of Prometheus and Grafana, I have created a separate workflow diagram here with all the required steps. Okay, so you can very well refer to those documents. So if you consider this document here, this document will be giving you a clear picture about the installation configuration of Prometheus. So this is the official page from where you can able to download Prometheus. And once the Prometheus is downloaded from that page, you need to extract that package and create a service out of it. Once the service is ready, then you can able to start the service. So Prometheus by default runs in port 9090. So we have to enable the port actually. And once the Prometheus is installed and if it is successfully up and running, you can able to configure the node. So the node configuration details can be extracted from the same page, and this also should be run it as a service. So we have to explicitly create a service for node export to the target machine. And upon this, you can able to integrate your Prometheus server in Grafana. So Grafana also we have to configure separately in a same server, or it can be different server. And Grafana is just for visualization, right? So it is also service running in port 3000. So first thing is, let's get into the instances and update the security group. Let me edit the security group to add the required ports. So you'll be adding nearly 3 to 4 ports for this enablement. Let me edit this inbound rule and add the rule here. Just for the sake of demo, I'm adding all traffic and with all area range, saving the rules. Right. So now that we have updated security group with all the required port numbers, and let's get into this document to download Prometheus. So this is the official page from where you can able to download Prometheus. And here you can able to see there are various Prometheus components. Like this is a Prometheus executable package you can able to download. If you want to install on Windows means just download the zip file and extract it and create environment variable for that. Similarly, if you want to install alert managers or node exporter for agent, you can even refer all the details from the same page. Clear? So first let's get into this page and try to identify the version. So for Linux environment, you'll be using this Linux AMD 64, this version. So I think 38 version, right? Let me check if the version is available. If it is not available, then we can go with the latest version. So very simple, just right click on this link and copy the link address. If you want to download any of these package, just right click on this package and copy link address and go to your Windows, Linux environment and use wget command. So the link, whatever you copied, it will be available like this. Okay. The link, whatever you copied, it will be available like this. So once the link is available, you can able to use wget command followed by the link to download the package. So now let me execute this command, wget command, to download it. So as of now in root directory, I don't have anything. It should be done on the monitoring server. So in my monitoring server, I'm going to execute a wget command followed by the link address, whatever I have copied. See, it is available. So it will download one tar file. Correct. So once it is available, you can simply use the tar command to extract this. Yes. So upon extraction, if you say ls, you should be able to see the directory. See, this will work in both Linux, CentOS or AWS, Amazon Linux 2, or in Ubuntu also, the same process. Yeah, even you can use Ubuntu machine, that's not an issue. So now that we have the commands available, so this is what directory, Prometheus folder, which we extracted. And if you get into the folder, you can able to see the executable. Prometheus is executable. And this prometheus.yaml is a configuration file. Default properties of Prometheus are defined in this file. So using this Prometheus, you can able to run your Prometheus tool or a service, and all these Prometheus configuration can be defined in this YAML file. Like if you want to add a new target node, the IP address of the target machine can be added here. But now this is not a service actually. Okay, this is not a service basically. So what you can do means you can able to create a service out of it. So if you see here, the service itself not found. That's what the basic property here, right? So your Prometheus just a package that got downloaded. It is not a service package. So we have to create a service out of it. So in order to create a service, it's very simple. You just need to create a service file in this path. So vi etc system d and system. So under this directory only all your services are getting defined. Even if you talk about a Jenkins service or Docker service or Tomcat or any Nginx service, whatever you run on your machine, all the services in Linux environment will be added to this particular path. So here only you can able to see all the service definitions. So the same directory, we're going to create one Prometheus service. And to create a service definition, the process is very simple here. So this is a template. Okay, this template you need to create from the scratch. This you can able to copy from any existing service which is already running. Let's say if you already have a Docker service up and running, means the Docker service file will be available here. Just cat the content, read the content of the file, you'll be getting this content. Thing is your exec start. So exec start, that is going to identify the directory where your Prometheus executable is available. So if you can see my file here, so this Prometheus executable is available in this directory under root directory Prometheus 2.38.38, right? So this is what the directory. Under this I have Prometheus executable. And using for this Prometheus executable, I need a config file to be identified. So the config file also present the same path, Prometheus YAML. So these two parameters are very much required in your service definition. And apart from that, the unit service and all just for iteration. Even if you're not coding this also, it takes by default, because every Linux machine for server definition, there'll be some default properties, when to start, when to restart, all the stuff. But the very important thing is your exe start, and unit can have some description about the service. What is the name of the server and the documentation from where you can able to access it. This document I just took it from the link which I sent to you. You can use the same link for reference. That's it. So all we're going to do is we're going to create one Prometheus service now. So just run this command sudo /etc system d system and name of a service. And here in the service definition page, you can copy the content. All right. So if you're using different version of Prometheus, just ensure that you have a given a valid version. So usually in real time and all, right, they will never mention the version number here. It will be like a generic folder, so that even if they upgrade the tool also, they don't need to update the file. It will be like just a simple like root/Prometheus directory. That's all they will keep. So name, whenever you name any directory, don't be specific about the version number. If you are specific about the version number, then honestly you need to update it whenever you upgrade your tool. Let's save the file. And once the file is saved, since we have updated a system component, okay, under etc system d, right? So we have to restart daemon, and then we have to check the status of Prometheus and then start the Prometheus. So now if I run these commands, see your daemon is restarted, and now we can see when I say systemctl Prometheus, now it says the Prometheus server, it is inactive. But earlier case when I issue the same command, it was saying like not found. Sorry, Prometheus could not found, right? Before creating a service, when I execute the command systemctl status, it says service not found. But now it says inactive, because we have defined the service in the config file. So now we can able to start it. It started. So let me check the status now. It is up and running. So Prometheus is up and running now. So once the Prometheus service is up and running, all that you can do is you can go to your instance monitoring server, copy the public IP address of that machine, and use the port number. The port number, whatever associated to that Prometheus. So as I said, Prometheus runs in port 9090. So just use the port number, and that's it. Using this, we should be able to see Prometheus is up and running. So this is a very simple Prometheus dashboard, which we can able to use for our reference. Just for reference, okay, we can't rely on this in production environment and all. Like if you want to quickly verify the Prometheus query or test the Prometheus prompt kill queries, we can able to use this. That's all. So here this expression field, right? This is a text box. So here only you'll be giving all your prompt kill queries. Like it's all like a key based. Like if I say up and execute, you can see it is just going to show me the list of servers that are associated to the Prometheus now. As of now, it is having only local host, right? We haven't attached any target machines. So it is having only one machine that is a local host. And graph, what I can see here. It's a graph view of that query. Got it? So from where you can able to get this expression means the expressions, whatever you can see from the help menu, or I'll be giving you one link now. From the link also you can able to understand the queries, prompt kill queries. It is not mandatory to go through that for interview and all, but just for information. So now if you look into this dashboard, right, it is not that intuitive. Okay. So we have certain queries like Prometheus query examples. So from this, you already can able to get some queries of Prometheus from QL. Okay, so these are all some prompt kill queries. So what are things you are seeing here in this page, in the parameters? This is what you can able to see in this document also. But you need to have some fundamentals about the prompt QL to handle this. So it's all taken care by the monitoring team. They know what to do. They know which resource they're going to monitor, for what purpose they're going to monitor. So based upon their specification, they can able to give any expression on this field. And if they execute, it will get executed. For example, consider I just want to monitor the, what is it called, CPU utilization of a server. Or if I want to monitor the memory utilization of the server. So these are some queries that are collected as part of that document. Okay, so this is one of the examples. And now we'll see how to configure the node. So when it comes to node configuration, you have to install the node exporter in the target machine. So let me get to the target machine here. And here in this target machine, all that I can do is I can simply download this node exporter. So this node exporter link also available from your official documentation itself. Like in the Prometheus downloads page, you should be able to see there's something called node exporter. Just right click on this and get the, take the public, so what is it called, link address. Take the link address and use duplicate command to download that file into your local machine. Just copy this and have it here. It is extracting the content, downloading content, and you should be able to see the content is available here. So we can quickly extract this by using tar command. See, this document is a static file, okay? The versions, whatever you can see here, it will be available for now, but maybe down the line after 6 months, if you want to work on this, you can't rely on same document because the version might not be available, right? So if it gets outdated, that's the reason I'm just showing you how to download the package from internet. So from here, just get the link and access it. So we can't completely rely on the document for a longer term. That's what I'm saying. So copy this and run it here. That's it. So it's a very small piece of code, okay? Just an agent. It doesn't require any config files also. See, it has created one folder, and under that we have a node port exporter cd to node. That's it. So node exporter is the name of the agent. And this also needs to be executed as a service. In my target machine, I have to run all these things as a service. So let me create a new service for node exporter. Let's create a new service for node exporter in the target machine. Go to insert mode, and we can able to create a service here. So here for this node exporter, we need only the executable. There is no config file associated to this. And the exe start just specifies node exporter and save the file. Once the file is saved, you can able to restart or start your daemon, reload a daemon, and start the node port service in the machine. That's it. So now the status is my node exporter for this Prometheus server is active and running. And always node exporter runs in port 9100. This is a port number. Node exporter runs in port 9100. So now that we have configured our agent in the target machine, which is already up and running in port 9100, so we have to link this machine to the monitoring server now. So to do that, all that we need is we need the IP address of the target machine. So before that, if you say vi prometheus.yaml, go to insert mode, and here you can see the static configs, right? So under static configs only, you can able to keep your target server details. So you need to get the private IP address of the machine. So go to target server, take the private IP address of that machine, copy the private IP address, and here you can able to change it here. Okay, so this is it. So this is what the targets. I just want to add this target to my Prometheus monitoring server. So just add the target like this. If you want to add a number of servers, you can able to follow the same procedure. So ensure that you have node export running that machine with proper port number enablement, and then refer that IP address of the target machine in your host machine, that is in your monitoring machine, and port number 9100. Just save the file. Once the file is saved, you need to restart Prometheus service. That's very important because we made some changes in the configuration, right? Which was being used by the service up and running. So now let's restart Prometheus. That's it. So now that we restarted Prometheus, and if you go to your Prometheus server now, and here if you refresh it and execute this again, see, I got my new node added as a target node. Can you able to see? Hope you're listening, right, all of you? So now that we have installed our Prometheus node exporter in the target machine, and using that, we can able to access the node. We can able to access the same node from your Prometheus server. That's it. So this is what the basic configuration behind your installation and configuration of your Prometheus servers. Okay. Any question? Any question here?
No. No.
Okay. All right. So now that we are done with the Prometheus installation and node configuration, But if you look into the query here, let's say I want to run some query, the query whatever I process, like if I want to check the CPU utilization of the server, means I can simply run the query here and execute this. That's all. So this is what we'll be getting it. These matrices and all will be managed by your monitoring team. They knew what it is actually, and the graph also, it is not that intuitive. Like if you want, you can produce a time frame for every 5 minutes. So what it is actually showing, what is the content of it, we will not have any clarity about it because it's not that much informative, right? So all that we do is we'll be integrating this in a Grafana. That's why we use a visualization tool like Grafana here. Okay, from here. So I'll ping you this link in chat window for Grafana.
So you will have these links in the class notes as well, right?
Yeah, that's right.
Okay, thank you.
See, this is a class notes which I'm going to share with you, right? This is a class notes and this is a document, installation document. So this document contains everything. So now that we are going to, I just pinged you the link in chat window as well. So now if you go to this Grafana downloads page, right, you can able to see it's a very interesting documentation page, okay, where we have a huge list of resource definitions for various streams. But before that, you need to identify the edition. So if you want to do some POC on this component, if you're new to this, and if you want to understand the capability of Grafana, you can simply use open source version of Grafana. But at the enterprise level, if you want to implement, you'll be going with the enterprise edition. Correct. So it, for training purpose, you can use open source because enterprise edition is a billable entity. At enterprise level, you can use it, but for training purpose, we can use just the open source version. And in which machine you want to install, whether it's a Linux or Windows, depends upon that. You can able to choose the installation process. Correct. So we are going to use the same process what you've seen here.
Okay, so Prometheus is totally open source. There is no enterprise version.
Which one? Prometheus is open source, yeah. Prometheus is open source, but Grafana is not open source. Grafana, we have enterprise edition also. For a non-prod or for POC level, you can able to go with some open source version. So now that while downloading it, please ensure that you choose a valid open source edition. And since we are using it in our Linux machine, you can use the same command, wget command, to download the package. We check if the package is available. So here, what we're going to do means we are going to download and install Grafana on the same machine where we have installed our Prometheus. Prometheus and Grafana can be installed on the same machine. Technically, it's possible, but in real-time environment, as per the best practice, we never have the monitoring server and the visualization tool on the same server. Because that was especially in a multi-cloud platform or multiple environments, using Grafana, we can able to visualize any of the monitoring matrices. It is not just to Prometheus. Even you can able to use your Azure monitors, AWS CloudWatch. All these things can be integrated with Grafana. So let's say I'm working in a hybrid and multi-cloud model. I have my local virtual machines, which is running an on-premise environment. And also I have a multi-cloud platform like AWS and Azure. So there are lots of resources running in all these three platforms. And I need a single interface or a dashboard that can able to monitor all these three environments from a single dashboard. So further, what I do means I'll be installing a Grafana in a separate server, monitoring server, or the server is available for administration activities. And I'll be connecting to my remote servers through what is called Prometheus. So once it is done, we can able to start utilizing the Grafana dashboards for extracting the data feed. So let me download this Grafana now. wget powered by Grafana. So this link also you can able to get it from the official page, like what I was showing you here, right? There's a link. It's available here itself. Okay. So now we have Grafana downloaded, the RPM package is downloaded, and you can able to just install that RPM package. Grafana is not like your Prometheus, okay? You don't need to manually create any service because it is running through RPM package. It automatically starts one service and runs in port 3000. That's it. And let's start the service. The same systemctl command, okay? Anything is fine. See, now the Grafana service is up and running. And we have installed Grafana same monitoring server. So all that you can do is you can go to the monitoring servers, take the external IP address of the machine, public IP, and then use the port 3000. Right. So that's it. So now that we have installed Grafana and it is up and running. So now for the very first time when you access, it will ask for the credential. So default username is admin, small case. And password also just enter admin. So this is a default username and password for Grafana. I just documented in the notes also here. Somewhere, yeah. I just kept it here for reference. And once it is done, then you're done with your work. So just enter the default user ID password as admin and log in. So since the very first time, it will ask for the password change. If you want to change the password, you can change it. Otherwise, you can simply skip this. So now we can see the intuitive dashboard of Grafana. Like this is the home page. So from here, you can able to browse through the dashboards, create dashboards or create a new dashboard, or you can able to go to the settings for data source, teams or plugins, anything. So now as per the architecture, what are we going to means we are going to add this Prometheus. We are going to add this Prometheus as a data source to Grafana. So we have a concept called data sources here. If you click on this, you can able to see Grafana supports a huge list of data source. Right? It is not just for Prometheus. Okay, we have a very huge list. Even I told you, right, in multi-cloud platform or hybrid environment, if you have your AWS CloudWatch or Azure Monitor or Google Cloud Monitor, so all these things can be considered as a data source to Grafana. Even your application monitoring tool like App Dynamics, Azure DevOps Services, Datadog. So what are the data that is generating as part of this that can be considered as the input or data source to Grafana? Right. So InfluxDB is one of the time series database. Similarly, Graphite, OpenTSDB. All these are time series databases. So now in our case, we are going to use Prometheus. So just click on Prometheus to add as a data source. So once you click on Prometheus, right, all that we need to take care is your URL, Prometheus URL. If Grafana and Prometheus are running on the same machine, you can simply say localhost : 1990. That is the Prometheus port number. But if in real-time environment, if you have installed Prometheus in different server and Grafana in different server, means then we have to give a complete IP address or DNS of that. So it means This is a Prometheus server, right? This is the Prometheus URL. So, correct. So this URL I need to specify in my Grafana dashboard configuration. Simply like this. Okay. And if it is present in different server means if it is having any access control like authentication, if you have anything like key-based authentication or token-based authentication, you can able to pass all those authentication here. Basic authentication can be password-based or key-based or token-based. If it is not there, you can simply go and save and test the configuration. See, now the data source is working, it is connected. My Prometheus is connected to my environment. Clear? Any question here? So all that we did is we just configured our Prometheus server and added Prometheus as a data source to Grafana. So now I can able to see Prometheus connected to Grafana. So what next? What next? So we can simply go ahead and create some dashboards. So just go to your Grafana homepage. And from here, you can able to see there is an option to create dashboards. Okay, you can browse through the existing dashboards or you can create new dashboard. Click on this new dashboard creation and it will allow you to add some panels. So dashboard means it's a collection of panels actually. So each and every panel is meant for some tracking purpose or monitoring purpose. So now if you look into this process here, I'm going to add a new panel. Just click on the add new panel option. It will take you to the panel configuration. So in this panel configuration, the very first thing is the data source. So if you can see here, by default, it is pointing to default data source because we just added a new Prometheus data source there. Like this, how many data sources you configured? All the list will be available here. Got it? It can be your Azure Monitor or AWS CloudWatch. Whatever you configured, everything will be available here. You can able to choose from the list. Once you choose this, the next option is your panel details. Okay, like what type of chart you're going to use. There are various types of charts represented here. It can be time series database, time series chart, or statistics bar chart. It's all how you're going to visualize the matrices. So let me give you one query here for first let's see about this one. So this is something meant for CPU utilization. I just copied from the official documentation, nothing else. Correct. So simply use it in your code. So from this configuration page, you can see there's a code option. Click on the code button. It will open up a field for expression. Just enter this query. See, this query is getting executed now. And if you want, you can able to customize this. This is for last 6 hours. You can able to customize to last 5 minutes or 30 minutes like this. Okay. And this is of time series chart. If you want, you can able to use a bar chart, anything like this. And then we can able to give the title of the page. So I said this is for CPU utilization, right? Just give a title as CPU utilization. Okay. And leave all the parameters default and click on apply. That's it. So this data feed will be collected for every 15 minutes or every 5 minutes or 30 minutes, depends upon the metrics you choose here. So we can able to customize this at any point of time. Got it. So this is a monitoring team will be continuously monitoring the infrastructure based upon this matrices. And not only that, if you want, you can take a backup of it. If you want to create a new panel out of it, just go to this option, expand this. You can see there is an option called more and duplicate. Just duplicate this panel. Similarly, you can able to duplicate the panels. So once the panels are duplicated, you can go and edit the panel. Just click on edit. And what you want to do here, you can try with different script. So this is something on memory utilization, this query.
Yeah, so say this utilization of the other machine,
Yes,
right?
that's right.
Which
That's
we
right.
connected to Prometheus.
Yeah, that's right.
Yeah. Okay. And if you
That's
have
right.
like five machines connected to Prometheus, then their five dashboard will become or will one
That will be
how
handled through a query itself directly.
for each.
Yeah, in query you can able to apply some filter. The target parameter is there, using the target, which target you want to manage. That's the reason we can able to add a number of Prometheus definitions. Like we can have the dashboard created for a number of servers, like for each and every server.
Yeah, but Prometheus server will be one, right?
Prometheus
One
server is
server
one. I'm
and
talking about the
multiple.
target. I'm talking about the target here. Assume that this query is meant for target 1. Similarly, you can apply some filter and write another query for target 2. Like that, if you want to represent each and every targets in a different dashboard, it's going to create it. So now let me save this for now. So let's take this example itself and let me save this one. This is for memory utilization. I can name it. Apply this. Okay. So this is just a collection of panels, right? So assume that these panels are created for one target machine. Similarly, if you want to monitor for another machine, means you can create one more dashboard here. See, it is asking for saving the dashboard. Just click on save dashboard. Just give a name, valid name, and save it. So like this, you can able to create n number of dashboards in the Grafana here. And whenever you want to add a dashboard, just click on new dashboard and add the configuration for that. So Prometheus server is one, but the target can be any number of targets, right? So each and every target you can have a separate dashboard or panels. All right. So that is how we just manage our dashboards and panels in Grafana. Any question? All right. So just to have a understanding of this, how the services are created, how it is executed, all the stuff. But when it comes to implementation, definitely we need inputs from the production support team and other guys. Directly, we can't implement this. Right. And this query also, this PromQL, right? Query whatever I shared with you. Sorry, this one. So if you find time, you can practice it. Otherwise, it is not mandatory. Okay, we are not going to use, even in DevOps experience, I never used all these things in real time. So in which situation we'll be using it, means I'll tell you one scenario. Consider I'm managing my entire DevOps implementation. Okay, so for DevOps team, we do manage some servers. Like it can be your Jenkins master, Jenkins nodes, and we'll be using our build servers, dedicated build servers for Docker, right? So if I want to ensure, let's say I have a Jenkins server. In my environment, I have a Jenkins production server and non-production servers. So production servers will be up and running all the time. That is for sure. But whether it's up and running or not, how will get to know that? Manually, I can't go and check, right? So what I'll do, I'll be creating some monitoring mechanism there. So I do use Dynatrace. Using Dynatrace, I just configure my uh, Jenkins servers as a target to Dynatrace, and using the same kind of setup, like how I created dashboard, how I created the configuration with the same set of configurations, but depends upon the Dynatrace, the user interface will be different. That's all. The parameters, whatever you're seeing, right? Based upon information, we can able to quickly work on that also. So just identify target server there, and once the server is identified, you can able to set some time frame. like how frequently you want to monitor it and send the feed. So based upon time frame, we can able to monitor this target environment. And if anything goes wrong, we'll be getting notifications also. Similarly, your Jenkins servers and all will be a very frequent activity because especially non-prod environment, production environment, there won't be any trouble because we just maintain production servers in such a way that it won't be down for any reason. We'll be running some automated scripts that will clean up the space, that will clean up the unwanted junks and restart the server if it's not up and running automatically. All those things we'll do for production. But in non-prod environment, consider we have a non-prod environment and I have various development teams involved. So each and every team needs their own, workspace and build servers, right? Like they might be developing a Java application or Python application. So assume that one of my development team, they submitted the build CSD pipeline to perform autumn build and artifact creation. So what if this job is not responding, right? What if the job is waiting for a node to be available? The chance of the slave machines might be down. So once you trigger a job, the job will be in a waiting state. So all these reasons might create some inconsistency in the environment. So before it goes create any huge impact, we proactively monitor the infrastructure and try to avoid the downtime. That's what the agenda here. Hope you're all getting this right.
Yes.
Okay. So I'll be sharing all these artifacts, all the documents, whatever I have with me. Whenever you find time, just practice it. And if you are 100% confident, you can highlight in your profile. Otherwise, you can take a call. But I strongly recommend please go through your Docker, Kubernetes, Jenkins latest stuff. What are topics we covered, especially in Jenkins, Git, Docker, and all? It's all very important thing. So please try to cover it up and add it in your profile. That's something important.
Yes, I so like while building our resume, right? We will add like all these topics which are
Yeah.
covered in
See,
the
as part
website.
of your
Okay.
DevOps training, you must have gone through something, right? As part of the training program. See, what you can say means you can highlight yourself as a trained resource. So during a training program, you have all these experiences, but you don't have any real-time experience on this tool. Like that, you can able to highlight about Prometheus and Grafana. Like
No, I'm not talking about this for this application. Like oral jobs. Okay.
okay, what is the question there on
Yeah.
DevOps?
So yeah. So like we will build our resume based on like Git, Jenkins, Docker, Kubernetes. Okay.
Yeah.
But we don't have real-time experience. Okay. So like how we can like do we need to create dummy profile and we have to like
No, what is the
learn
current profile actually?
or
What
how we
currently you must be working, right?
I'm developer.
Yeah, what is the
I'm
current
developer.
profile?
Hello.
Yeah, what is the current profile?
Am I audible?
There are a lot of
I'm
background
developer.
noise.
Developer.
A lot of background noise actually.
Hello. Hello.
Yeah, Dhananjay, I can hear you, but a lot of background noise. That's what I can hear. So I can understand that you are a developer and you want to prepare a profile, right? So point here is, being a developer, you'll be considered as a DevOps trained resource. Okay. And if you already have any tools in your real-time environment, like stating that like Jenkins or other stuff, you can use the tools in your profile. Got it?
Okay.
And as a DevOps engineer, what are things we have covered so far? You can add all these things as your training knowledge. You can say like I am a developer with some DevOps skills.
Okay.
It will work. Definitely it will work. How many years?
Yeah, 6.5 years.
Yeah, that's well and good. Are you do you get chance to interact with any of your DevOps team members in your company or like?
No, actually, we have like one DevOps team, so we were like only used to see that those Jenkins jobs, like what like they are saying like this because of this dependency, your job has been failed. Please look into that. Yeah,
Okay.
that's it. We don't have like other server access to,
Okay. Yeah, then it's
and
yeah, then that is the case, right? I strongly recommend just interact with them and try
okay.
to get the list of DevOps tools they're using currently.
But
Okay.
in our project, actually, Azure they are using, but that is fine, right? No.
Yeah, that's fine, no problem. All that you're going to do is you're going to understand the process, how they do, what they're doing actually, right? What is the related activities, and try to relate it with the things whatever you learned. And if you are really serious about DevOps, if you want to move towards DevOps, means you can first check internally within your company. You can just upload your profile and ask for the opportunities like you are a trained resource now. You are interested to move to DevOps means if there is any opening internally, you can move it towards that.
Yes,
Got
yes,
it?
yes.
So as a smartest move, that is what I recommend. Okay, instead of trying from outside, if you already have a DevOps practice in place, definitely you'll be having your internal training programs, everything will be there, right? So only thing is
Yes, yes.
it's all depends upon your interest, how quickly you can able to learn and all those stuff. So first try, I strongly recommend people who are working, just try to switch your career within your company. Got it? From development to definitely you'll be getting an opportunity for sure. Talk to your manager, showcase that you've done your certification, you want to move. So it might not happen immediately, but gradually it will happen for sure. In the meantime, you can upload your profile in any other external job portals like Naukri or your LinkedIn and look for opportunities. Got it? And
Yes,
whenever
yes.
you get any opportunity interview calls from external resources, just try to attend the interview and understand what they're expecting from you. Clear? Based upon you
Yeah,
can able to improvise, you can prepare for your interview and don't leave your job for any reason. Okay, that is a very important thing.
no, no,
Okay,
no.
don't
Yeah,
think that you are not getting time for preparation. You are getting some calls from outside, but still you don't find any time to prepare because of the hectic job. Don't think all those things until you
yeah. No,
get
no.
your permanent job outside. Don't leave your job. Okay, that is very be sure about it. And your very first preference is just move your career within your company. Just talk to your other teams, other team members, interact with the DevOps team especially, and tell them like you are interested. Talk to the manager. If they have opportunity, they can pull you inside, right?
Yeah, I
So
think
that
that
is how
is
you can able
the
to move.
first, first step.
Sorry.
I think that is the good like first steps
Yeah, that is
to
what
like
recommend actually. Okay, because you already have your valid employment, right? So just stick to that. Even if you put your own papers, also they will HR will ask you why you want to leave a company. Means if you say you are more wanted to work in DevOps, means definitely they'll try to find some opportunity in DevOps with other team. They won't easily leave any resource that too in current market situation, right? So if your aspiration is
yes,
more
yes.
towards DevOps, means before dropping your papers, you can talk to your manager and showcase your capabilities and your skills, and down the line definitely you'll be moved to the next profile. That's not an issue.
Yeah, sure. I follow that. Yeah,
Sorry.
thanks, thanks for. Yeah, I will follow that way only. I think. Uh,
Yeah, yeah, that's right.
yeah. Thank you so much for.
Yeah, sure. So yeah, I'm done for today. If you have any questions, I'll address your questions now. And for tomorrow's session, we'll be having a complete review of all the modules what we covered, along with the detailed demo. Like starting from Jenkins, what are the modules we covered? I'll try to integrate everything together, and we'll see a complete end-to-end pipeline. Okay, which can be automated through your Jenkins. Hmm? All right.
Okay.
So please let me know if you have any queries now. Yeah, sure. I'll be sharing these documents. This Prometheus installation guide as well as the class notes, and then the deployment and pod definitions is whatever I have. And I'll be sharing something related to your service. That service definitely tomorrow I'll share. How to create a service using a manifest file and the namespace and all we share it tomorrow. Right. So tomorrow is the last session. So please try to come up with a lot of questions and utilize the time effectively. Any questions, please let me know, guys.
No questions. Thank you. Thanks.
Yeah, sure. All right, guys. So thank you. Really appreciated your time. Tomorrow, let's continue with the detailed demo.
Thank you, sir.
Yeah, sure, sir.
Yeah, sure.
Thank you all. Thank you, sir.
Yeah. I'm here. Okay. If you have any queries, you can, especially in the Kubernetes, right? You were asking something on Kubernetes. If you want to try something, let me know. We can try now.
Actually, my doubt is, I'm from service now, so I have resigned like a few months back. So about this project, what I should mention, those all I need to discuss. In resume, I'm talking about resume.
Okay.
What I need to just, so like I'm asking about projects I have worked on this, so I need to explain it. That is my doubt actually.
Okay. So you are currently working for in a service based means like what is the current profile?
Service not developer, as a service not developer.
Developer, right?
So due to that, like Java, I am afraid of that Java. So that is the reason I have quit from that job and I'm trying for this DevOps.
Okay.
Also, I want some like FAQs. If possible, I don't want definitely I don't want that. But so in service now, the trainer who has trained me, he gave me some not only me, our team like 350 or 38, I don't know exactly. So he gave some questions, and if, for any interview, if you check that those questions, everything will be in that question, so in that perspective. But other than that, we can't just.
Okay.
So I'm not asking that I want now like jobs and everything. Just I'm saying so some exactly. So that we just thorough about that those questions and everything.
Okay. Yeah. So for each and every module in DevOps, right? If you are preparing for interview,
Yeah.
there are a lot of FAQs available online.
Yes, yes,
Okay.
yes.
So just search the FAQs based upon the year, like Jenkins FAQs 2023. Got it. So you'll be getting the more relevant questions there and along with the real-time scenarios also. So you can simply follow. If you go through few documents like that, it will be more than enough
Okay. And
for
this is
interview.
the conclusion. Somebody will ask what you have faced any problems, how you just resolve them. So I don't have any practical here.
See, you can't showcase as experience. Are you going to prepare any fake experience on this or what? What's the plan?
No fake, nothing.
Then why you worried about it? Okay, see, you have a genuine experience now, right?
Yes.
And you are interested to work in DevOps. So
Yes.
for that, you have learned something, you have completed certification, and during certification, you learned these many things. So you can highlight yourself as a trained DevOps resource. That's all. So definitely from a trained DevOps resource, they never ask anything related to the real-time scenarios or the challenges and all those stuff. They will
Okay.
check how much you are strong
You're
in the
asking me
fundamentals.
that, you're asking me to just like fresher only. Am I right?
Yeah, yeah.
Okay. So I don't know exactly. One of my friend he said they are asking for only 4+ years of experience. So then I said okay, I'll talk to my trainer and I'll follow his instructions. Then I will go ahead with it. So I said that only. So if you just showcase like 4+ years of experience, there will be a lot of headache for me because they will expect more from me.
No, no. See, you are 4+ years of experience in development, right? Not in DevOps.
Not the.
Huh. That is what you're going to highlight. Okay. So are you going to convert this entire 4 years as a DevOps profile?
Mm,
Are you going to showcase yourself as a 4 years of DevOps
See, my
resource?
plan is I have worked like 3 months with not 2 years. I can say 21 months in this service now developer as a service now developer. So in that in experience and everything I got as a software engineer, not like service now developer.
Uh,
So my plan is I want to convert those and also I have worked in this DevOps only.
See, but I don't think that will be that much easy to do that because your current destination is software engineer, right?
Yes, yes.
If it is generic like tech lead means you can easily convert as a DevOps tech lead.
Okay.
Okay. So software engineering means it is nowhere, it is completely based upon development only. Everyone knows,
Okay. Yeah.
right? So if you want to proceed as a genuine profile, I strongly recommend just highlight yourself a DevOps trained resource.
Oh,
Correct.
okay.
So
So yeah. Because
or or if you can able to manage any projects internally, like within a company, that's what I ask you to interact with your team members, DevOps team. So understand what they're doing, for which initiatives they must have implemented DevOps, right?
yes, yes.
So you're using Jenkins as a user, right? So how they created the project, what are the things they have used. So you can able to collect those information and add it to your profile directly.
Okay, okay.
Okay.
I understand. So I'll just
So
do.
or in your profile you don't mention as a software engineer.
Okay, okay.
In your resume, don't mention as software engineer. How many years your experience? It's a 4+, right?
So,
Over.
no, my just it was a suggestion from one of my friends. If you just
No, no, I'm asking about you actually. What is your overall experience?
that genuine experience is 21 months only.
Okay, so not even 2 years now. So you can, okay, then you can mention like associate. You can consider like a DevOps associate. That's all.
Okay.
Got
So,
it.
and one of my friends said, he also explained me about fake. So I said I don't want to fake because it will be problematic. For these 3 months or 6 months, it will be good. After that, definitely they will again re-verify. At that time, I will definitely they will kick me out of class. So I said I don't want to all fake. So I have gap like now I am not working. So I resigned last year December.
See, I'm not sure what is your current progress there, how much you are prepared about DevOps and all. So if market is really good and if they really need a resource, definitely, even if you are working in a different stream also, they will put you inside if you're a trained resource. Because during the interview, what is your capability on the DevOps? That is what the main concern here. Got it? And fake profile is different. Highlighting yourself as a different profile is different. Like, for example, consider you are not working now.
Yes.
Okay, you are not working. You don't have any experience on paper. If
Yes.
you're preparing any fake document and if you're trying to attend an interview, that is a fake profile, right? I get your point. But you are already working for a company and you are working for a particular project, you are getting a regular pay scale, and you are in a project now. That is very important thing. So in that project, which technology you're working, that is secondary. Whether you're working in Java or DevOps, that is secondary. That can be anything you can mention. So that's what I'm saying. If you really want to move towards DevOps means in the last 1 year, you can say like you joined as a software engineer and due to some project requirement, you moved to DevOps team. Because of your aspiration, they just moved you to DevOps team, but still my designation is there as it is a software engineer. They will change it in a year of time. But I'm currently part of working, supporting my DevOps team to implement all these things. So I knew about Jenkins, Docker, Kubernetes, all those things. I just work with my DevOps team. That is how you can able to manage the things. So being a DevOps, being a developer, if you have a DevOps knowledge, mean definitely it's added value for you. Hope you're getting your point. Very good. What happened? Are you there or not? Hello, Prakash or what? Yeah, hello, what happened? Hello, Harshavardhan, right? Can you able to hear me? I think you are on mute. Hello, are you there? Guys? No, I can't hear you here. Looks like there's some disturbance.
Hello.
Yeah. Yeah, I can hear you now.
Okay.
So you're the one asking, right, about this?
Yes, yes. So just I connected through my mobile. I don't know why my laptop. So yeah. Yes.
See, this is what I was talking about. Currently, you're working for a company with almost 2 years of experience now, right?
Yes. Now I am leisure. So for past 10 years.
Yeah. So what you can do, you can just, prepare a profile stating that you are a DevOps associate.
Okay.
Correct. On paper, from your company, it is software engineer, let it be. But on your resume, you can mention like a DevOps associate so that at least your profile gets shortlisted for interview. So
Okay,
during
sir.
interview, definitely they'll ask you about your experience.
Okay.
So you can highlight like you joined that company as a software engineer and you worked there for 1 year. And due to some project transition, you were moved to DevOps team
Okay. Okay.
with the same designation as a software engineer. Designation will be changed in a period of time. Like that, you can tell them.
Okay. Okay.
Correct.
Understood.
So now you are supporting the DevOps team to implement DevOps for your applications.
Okay.
Correct. So you are involved in the Jenkins pipeline creation and worked in Docker, Kubernetes, all those things. You can highlight everything.
Okay. Okay.
Correct. So now, as a DevOps associate, how you support your application team along with the DevOps team members. That is what you're going to highlight in your profile.
Okay, sir.
So
Understood.
clear. So
So,
this cannot be considered as a fake profile. Okay. So
okay.
fake means like if you don't have any job and if
Yeah.
you are completely preparing all the documents in a fake means that is a fake profile. Now you already have a job. You are working in a current company. You have a payroll now,
Yes.
right?
Yes.
Only thing is the technology whatever you're going to use is well, you're using Java now as a developer. Now
Yes.
you are going to highlight what are things you learned in training program. Based upon this knowledge, you are just highlighting that you worked in DevOps.
Okay.
So no one
So
is going to come and check in which technology you worked, whether you
yes.
worked or not. That's what they will check. You whether your document, whatever you have, is a genuine document or not. That's what they will check.
Yeah, that is okay. And why can't I just simplify this as like 1 year DevOps associate and other like service now?
Other, you can do that, but on paper you should have something, no?
Okay, okay,
So
okay,
you should have 2 experience letter then for your initial service now and then this one, right?
okay,
So there is
okay,
no harm. See, even I have seen a lot of people here, people who are in development team, they are getting trained on DevOps tools and they are just doing some mixed role here. Developers also, they're involved in DevOps activities nowadays.
okay, okay.
Okay, so company accepts that. If you
Yeah,
are a developer with DevOps knowledge, means definitely there is a demand for you.
okay, sorry. So you're asking me to just tell them that I got chance to work in DevOps as well. So here I can explain like both like service now and also at the same time like DevOps also.
Come again?
So here I can showcase like I have worked starting like ServiceNow developer as a ServiceNow developer. Then I got a chance, so uh, I can say like
Work
that. I
in
can say.
DevOps. Yeah, work in DevOps. Yeah, that's right.
Okay, okay. So and other than that, I can't say I will work both the aspects like ServiceNow and also DevOps both. I can't say like that.
Yeah, you can't.
So yeah, I understood. Sorry. So this is my doubt actually. Then one small question, and after that I don't want to ask anything. So I have a like gap like almost 10 months. So how can I just I don't want to get some fake documents and it will be problematic not now after
No, no,
some
I'm not talking about the fake documents at all. You have your proceed with your genuine document itself.
yes, yes. But I need to manage these 10 months. I can say how can I manage?
What is the reason for that gap?
Actually, I work like credit source. I think you know that bank Switzerland.
Mm-hmm.
So some I can say from there and only bank got something like I can say financial issues. Don't know exactly. They didn't say many of them. They have just said you can resign. So not only me, almost we are 40 members of team, almost 30 members only who are working for the credit source
Yeah,
direct.
no problem. You can tell them. You can tell the same reason. Okay, due to some recession, we were getting into this issue, and because of that, I was having this gap. And during the time, I was not idle. I was preparing from certifications and all. You can showcase. That's it.
Okay, understood. So from
Right.
past,
You can talk about. See, everyone knows the global market scenario. Okay,
yes,
so there
yes,
is nothing to hide here. Even if you hide, also at one point of time, you'll get caught. So,
yes,
but
yes,
just be genuine. This is what the reason.
yeah,
Always your current status matters there. What is your current status? You're not simply sitting, right? You are learning something for your career, right?
yes,
Right.
yes,
And if your learning is going to helpful for their environment, definitely they will take you inside. So all that I can say is just go with the genuine reasons, and
okay.
only thing is just be prepared. Be prepared
Yes.
with all the
So here
technical things.
only solution is my output should be good. So if they ask something,
Mm.
they should be satisfied. Yeah, this Harshavardhan is okay. He's up to the mark. So they should think he is good for this. So we need to showcase with our knowledge.
Yes, that's right.
Yeah, I understood. Sorry. So I don't want to go this all fake everything. So it will be good for now, but in future it will be very problematic for me. Not only me, everybody around me.
All right.
Okay, sir. That was my point.
Yeah, sure, sure. Thank you.
Thank you. Have a good day.
Thank you. Bye.